then we'll be rocking and rolling. So,
all right, cool. I went ahead and started my stream though, just heads up.
no problem. Who would like to? Okay, we have the flat side going first. Of the two of you flat Earth fellows, who would like to go first?
I'll go first.
Okay, cool. Oh, wait, sorry, I can't see you. Who's it that said that?
Alan.
Alan. Okay, so then Alan, once you're done, you can basically hand it right over to Dominic without me interceding. And then once you're done, Dominic, I'll jump in to kick it over to the other team. Other team, when I do kick it over to you, Peter and Melvin, who would like to go first between the two of you?
Peter.
Okay. Cool. Here we go. Thanks for your patience. Let me just double check this.
We got a firmament dome reflecting on in his screen share.
Can you guys, if you can do me a favor, and not screen share until you're actually like presenting, because otherwise it scrambles the screen. Okay, thank you so much. And then let me just double check this. Dominic, Allen, Peter. Oh, let me just switch really quick. All right, thanks for your patience. And then here I go. 3, 2, 1, ready, set. Here I go right now. Hey, everybody. Tonight we're debating flat Earth versus globe Earth, and we are starting right now with the flat Earth side. Thanks for being with us. Alan, the floor is all yours.
Thank you, sir. Let me start the screen share. Entire screen share. Okay. So question. Can you use objects in the sky to prove the shape of the ground? Following the scientific method of observation, defining a problem, forming a hypothesis, and trying to falsify that hypothesis with a null hypothesis, we're going to analyze the two schools of thought here. Starting with our null hypothesis, we have the Earth is planar and measurements of curvature are dependent on the position of celestial bodies. Our alternative hypothesis is going to be the Earth is globular and measurements of curvature are independent of celestial bodies. Now we're going to examine evidence that should lead to a mutually exclusive outcome in determining the correctness of the shape of the Earth. So first off, we'll start off with maps, which goes back to the graticule in cartography and astrogeodetic surveying, which we're going to cover through here. But what we're going to start with is what a map is. A map is a graticule. It is a spherical coordinate system. A coordinate system is arbitrarily defined by Cartesian coordinates here. We have rectangular, cylindrical, and spherical. All of these under transformation are equivalent. And that is the beauty of the spherical coordinate system that is given to us on that uses the latitude and longitude lines, which are derived from positions of the stars, which is part of my hypothesis here. So as we look over at all these different map projections, we can see that they all look different. The land masses are in different shapes and different positions. Does that mean that any one of these is more invalid than the other? Well, no, of course not. The globe and an azimuthal projection are two representations of the same coordinate system. Now, one is just the favored projection, and it is said that that one represents the shape of the ground based on a cosmology that has incoming starlight from an infinite distance to take measurements of stars to say that the only reason that the starlight could be deviated is due to the shape of the Earth, which we'll get into when we cover geodetic surveying. So real quick, there are three families of projections here: azimuthal, cylindrical, and conical. All of those can be projected from a sphere, and we're going to be dealing with a celestial sphere, specifically one hemisphere at a time. And it should be further noted that the graticule, the spherical coordinate system of latitude and longitude, defines all units of measurement in modern time and in previous times. All units of measurement are a ratio of the terrestrial meridian, which is the distance from the North Pole to the equator. And if you take that out in nautical miles, that would, so we're 60 miles per degree with 90 degrees of latitude in between. you would get 6,214. And if you ratio that, 1/10 millionth of that comes out to be the meter. So that is what they're defining as a meter. And that also links back to the speed of light, where the speed of light traveling over one in meters is 39 inches. And that is how they relate the meter to the speed of light through through inches. And the inches obviously are a ratio of the metric system itself. So they're all interchangeable, and they all start with being defined by a fraction of the graticule of the coordinate system that is used to describe this place. So here we're looking at the representation of that with 69 miles per degree times 90, giving us the dimensions and ratio to define the meter. Now, when you cosine stars and use a set altitude, because you have the angle, the starting angle, and you have the altitude set at the length of a terrestrial meridian, because remember, the position of the stars, specifically Polaris, as you go towards the equator, is what defines the northern hemisphere of this projection. So anyway, when you follow that ratio, the law of cosines, you can computate a distance out of that. Now, when you take a zenith measurement of the star that you used as your reference when you traverse the land in units of measurement defined by the coordinate system, and you put your theodolite up there, you should see a star directly in the center of your telescope. But what they found was that the stars never are directly in their telescope, and they drift back and forth throughout the years. Now, they say that there's a precession that occurs where, Polaris used to be a Thuban or something like that, but the stars don't actually follow that sort of trajectory when they plot it out over time. If you look back at the almanacs, all the corrections, they go back and forth in the sky. There's no fixed defined point or preferred position for them. It's just an apparent position that's a snapshot of the sky based on the vernal equinox, which is called the first cusp of Aries. So then they went out to go measure they went to go take zenith measurements, like I just said, following the law of cosines, and they found that the stars were always off a little bit. Now, what they'll say is that you can only do celestial navigation and get circles of equal altitude on a sphere like this. Otherwise, the angles won't add up. Well, when you do that on a different projection map, it's going to look different, because there's going to be a different corresponding correction for the transformation. When you apply the correct transformation, because all these maps represent the exact same thing, there's a direct equivalence there, and it just looks distorted, but they all represent the same thing. That is the purpose of the graticule system and the symmetry of it. Now, here we're looking at astronomy, which defines the positions of the stars, and we should be noted here at the bottom. It makes note that the celestial heavens look like a curved dome, but it's no greater than the curvature of the Earth. And there's an equivalence between what you see in the sky versus the ground curvature in between, to create the illusion that there's that the sky is curved. Now, here we have all celestial objects in the sky are apparent to us. This is a manual from a solar panel manual. And this is describing how there's a true position of the sun, but what we see is projected in a dome that arcs around us in the sky. So we actually see it arc across the sky. And this is also for the moon, showing the same thing. Second. Same thing for the moon. So all celestial bodies can actually be considered at an equidistant web from us at that distance of 6218, which is that distance from the North Pole to the equator. And circumference is not mutually exclusive to a disk or a circle. So circumference, radius, all of that still applies applicably. Now, we see in curved visual space, which means that it creates a dome of vision around us. So we see in one hemisphere at a time when we're looking out 180 degrees at the sky. What you can see, you can consider all celestial objects at that altitude, and that's how they do celestial navigation, and that's how the map coordinate system is derived in relation to that. Now, what we're looking at here specifically, though, is an anticorpuscular shadow showing the relationship of how light in perspective bends objects around you. So here the sun is blocked by a shadow that goes across the sky. You'll see it maximally diverge at her zenith, and then it starts to reconverge behind her, completing the shadow. And this is all due to perspective. And if you're familiar with anticorpuscular rays, this is the exact same thing, but just a shadow. So do we have direct measurements of Earth curvature? Well, we have the geodetic surveying from mctune.net/se. You can go there and read all about the triangulation of the arc of the parallel. This is full of astronomical corrections and comparisons. People will often say the Earth is flat, the Earth measures flat, the Earth measures curved. Well, in reference to what? Well, it turns out it's in reference to the stars, which was the part of my hypothesis here. And when we look through the data sets, we get angles that are sub 180 degrees, showing planar measurements. But then after astronomical corrections and comparisons, the spherical excess is computed as noted in the glossary. And then we have deflections of the verticals, which is supposed to be the explanation as to why the stars are never in the correct positions. They say that that's due to the Earth's oblateness. This goes back to the Nautical Almanac and throughout the history of that, when they did surveying on different ellipsoid models to determine the eccentricity for the corrections that were needed for celestial objects. So what they're doing here is doing triangles in the sky, transposing them on the ground, and wondering why they don't line up when everything in the sky is apparent to us. So there's some mutually exclusive things to go over here that I'm going to present, but as we go through the debate, this is the geometric properties of shadows at sunset, circumpolar orbits for terrestrial navigation, and satellite orbits. We'll look at some of these over different projections and see if they truly represent north-south circumpolar navigation. And then, of course, we have Battle of the Beams, where radars were used to intersect at distances well beyond what would be blocked by Earth curvature to guide planes at night to do bombing runs over the course of a year. How much time am I at?
You got 4 minutes and 40 seconds.
All right, Dom, you wanna
You can go if you want, and I need just like 2 minutes. I did presentation about motion, so you can go.
All right, cool. Okay, so starting off with circumpolar orbits right here. What we're looking at here is you're going to be coming down the ball, then you're going to be coming up the other side of the ball. This is a true north-south orbit here. And then when you look at that on an equirectangular projection, you'll see the same relationship. It goes off the screen, and then this would be going down the ball, you're going up the ball. It doesn't matter which one, but it'll always be the opposite. So when you transform that onto an AE projection, what you would have is this. This is what it would look like. You're going up the ball, down the ball, back around, up the ball, down the ball. Now, when we look at all publicly available equirectangular projections given to us, they make figure eights in the sky. They make giant flower life patterns over the Earth. They don't represent the proper north-south circumnavigation. So all satellite orbits are evidence that the Earth is planar, as noted by how they never do any north-south circumnavigation. Now, this would be a feat of the globe. You would see projections like this, but you guys have never seen one, and you'll have to go back to look at it again because it's the only time you'll ever see it. So we're just going to continue through here. All of these showing the same thing. They're figure eights in the sky. Now we're going to look at north-south terrestrial navigation done from planes. There were several Pan Am flights that were done for like tourist attractions and world records, etc. So we're going to look at the routes that they plotted out on equirectangular. When you go through an azimuthal projection, you'll find that they're just making a big circle across the ground. Same thing for other Pan Am flights they did. And then, of course, the One More Orbit crew, which was trying to set a world record. And when you plot their route out, it shows the exact same relationship where there is no true going over the ball and coming up around the other side to do circumnavigation. And when called out on this on Twitter by our boy Gleam, shout out to Gleam, the response was to blame the marketing team for using a conceptual route and not the actual flight route that they took. So again, all publicly available representations of this do not represent north-south navigation, and that would be an absolutely mandatory feature to be, if the globe projection was the correct interpretation of the map. Now, of course, we have Battle of the Beams to continue off of that, where two intersecting beams over different distances, one 450 miles, the other 330 miles, intersecting at an altitude of 19,000 feet with a maximum beam divergence over target of 400 to 600 yards, respectively, depending on the starting location. And that would be geometrically impossible on a globe. In fact, the British, a few years prior to the radar system being used, said that due to their calculations, the radar system would hit Earth curvature at 50 miles and be completely useless.
1:30 left.
All right, that's all I got. I want to yield it to Dom.
Okay. I will share screen. Second.
In the meantime, folks, want to let you know DebateCon 5 is happening in Newark, New Jersey. just in case you're not able to find the screen share button. Let me know, Dominic.
I think I found it. Can you see it?
Yes, sir.
Yes.
Perfect.
Good to go.
Well, as Alan stopped it, first of all, sorry for my English. My main language is Czech, so I will be trying to speak as fluently as possible. As Alan said it, the Battle of the Beams is, as well as for me, is one of the best proof that the Earth is not a globe, because they were propagating radio waves on horizontally from the antenna that is like impossible to turn it vertically. So just like on axis, turn around. And the specificity of this propagation is that they had to like have really precise geometry of the beam. And the geometry of the beam was mechanically precise on the specific distance. And if you like do your math, and you can do it, the distance that they propagated is impossible on the globe. Like only way to maintain the geometry of the beam is when you propagate it horizontally and as like if Earth is flat, which is like for me it's very weird, because the plane has to fly in the beam all the time in the night, and they have to like drop the bomb on specific place, and the beams actually like have to cross over on the target, which is like you have to count on specific like atmospheric like the impossibility of two beams maintain the geometry and specifically drop the bomb on place where you need it is like for me this is like the biggest mystery, because like I know there's like some new evidence and stuff like that, but I didn't heard any good refutation on this Battle of the Beams. So for me especially is the one of the like best proofs, because if you take some other radio propagation, there's could be like why it could go and like some diffraction and skywave propagation and stuff like that. But in this case, the plane has to fly in a specific altitude and drop the bomb on specific target, which is like impossibility if you count everything. Do I have a time still?
I'll give you minute left.
Okay. So if you like count everything, because like we had the time to get like so many information about this Battle of the Beams, we have all technicalities, and if you count like all data, like if they propagate it from Mount Everest, from like if Stolberg or like Cleve were on the Mount Everest, and they would be like propagating from Mount Everest, they still like wouldn't be able to propagate the beam like over the Earth curvature if there was like any. So this is like one of the best proofs. And to like simplify it, I would say that we are here to debate the shape of the Earth, but we should like decide what is our like default position, because like when we like wake up and do we see curvature, do we like see some motion, or this is like our default position is that the Earth is flat and stationary, and then it could be like some other way. And if there's like some other way, then like the side who is claiming it's other way, it's their time to prove it, because like who has the positive claim, then he should be like presenting some evidence that it's different.
Time. We will kick it over to the globe side. I want to do a couple of quick housekeeping things. First, folks, if it's your first time here at Modern Day Debate, I'm your host, Dr. James Coons, and don't forget to hit that subscribe button, as we have many more debates coming up in the future. And DebateCon 5 is happening in Newark, New Jersey. Folks, if you are anywhere near the Northeast, we have no joke. Fight the Flat Earth will be there. Very popular globe debater. It's going to be a tremendous debate. Whitsitt will actually be there. That's MC Toon's brother. A lot of people don't know they're brothers. It is going to be such a good conference in Newark, New Jersey. Some people are actually coming to see it from England. I'm not joking. For real. That's how big it's going to be. It's in, oh gosh, I've been on mute this entire time. Okay. Folks, I've been on mute that entire time. It's very embarrassing. It's like my first time here. Look at Melvin. Look at how sad is how
I heard you
happy
over
he is.
here. It went out on my side.
Well, thank you. I appreciate that. Folks, a couple quick housekeeping things. If it's your first time here at Modern Day Debate, I'm your host, Dr. James Coons. And don't forget to hit that subscribe button as we have many more debates coming up, including the ones at DebateCon 5, our in-person debate conference featuring Fight the Flat Earth and Austin Whitsitt Gets It in Newark, New Jersey on February 15th. The tickets are linked below. What are you waiting for? With that, we're going to kick it over to, thank you for being with us, MC Toon and Peter. The floor is all yours.
All right. I'm going to try to share my screen here.
Ready for you.
All right. Can you see that? If I do this, can you still see it?
Now I can see it. I just have to crop it slightly, but give me 2 seconds. We'll be ready for you. Okay.
Is it better if I don't do full screen? All right.
This works. You're good.
We need to declare the term flat Earth today.
But we can't hear you.
No,
It's I don't know if it's just me. Hold on. Wait, hold on a second. I'm sorry.
Lagging hard.
I don't know if it's just me, but it sounds really robot-like.
Oh boy.
Is anybody else having difficulty in hearing?
Yeah,
he's
me as
coming in
well.
broken.
Roboting hard.
We
Testing.
might have to
Testing.
we might have to forego. Like, we'll give it another shot, Peter, but if it's this way, we might have to forego the PowerPoint.
He could like turn off his camera for the presentation. Maybe it helps.
That's probably what it is it's the PowerPoint and your camera are being zoomed into the call, and I think that's what's making the difference. So I would turn off your camera. Thanks for that idea, Dominic. And we'll see if this makes a difference for your audio. So hopefully you can still show your slides, even though your camera's not showing. Hopefully you can still show your slides. We can't see your slides though right now.
Can you share for him, Toon?
He freeze, like show it if you can see.
I don't have his presentation.
If you email it to me, I can share it for you.
I don't.
Are you still there, Peter?
Oh, he's not even there.
We lost Peter. Okay, don't worry. He's okay though.
He's maybe just trying to reconnect.
He'll be here any moment. In the meantime, let me just try to crop the screen down. Oh, Peter is back. In the meantime, Peter, can you hear me?
Oh boy. I can hear you. Can you hear me?
Yes. I think we at least have your audio, so it might be good if you are just going without your camera, because, well, more important that we have your audio than your video.
Okay, I'm gonna try just sharing this. Can you do that? Can you see this?
Let's see. We can see you.
I don't know why this is.
We can't. Let's see.
I didn't on purpose because I really want to show my slides.
Yes, we can see your slides
I
now.
worked hard on them.
Let's see if this works. Go
Peter,
ahead.
you could send them to me.
Let's hope this works, because if I sent them to you too, and then I wouldn't be able to press forward like at the exact moments, and it would be kind of yeah. Anyway, I guess I could like give a verbal cue, but that seems, I don't know. Let's see if this works. And you guys can hear me?
Coming in a little
I
distorted,
actually can't
but
hear you.
Yeah, it's not the best.
It still sounds pretty bad, even with your camera off.
All right. You know what?
Well,
I'm just gonna send.
Now it sounds okay. Well, like although maybe
Because
that's
he turned
you're
it
turning
off.
Because he just turned it off. It's a bandwidth issue.
Okay.
Man,
Narrowed
Let's
it down,
see.
lads. We know who
if
the
you
problem isn't.
If you send it over to MC Toon, and then MC Toon could show it on his side, because my side's probably
yeah, maybe I'll.
my side's a little bit probably maxed out with both OBS and then the stream and then the other stuff that I've got running for the stream. So in the meantime, folks, I do want to let you know, I want to give praise to our speakers as they are the lifeblood of the channel. So folks, if you watch Modern Day Debate, which obviously you do, if you're here, the speakers are what make this channel awesome. So we do want to say we appreciate them. They have busy lives, and we appreciate, for example, that Peter made a presentation for tonight. It'll just take a couple of minutes, folks. So relax. We'll be good. Just 2 minutes. No problem.
I might have to disconnect from the call for a moment while I upload my presentation to share it to Michael Toon.
You got it.
Because bandwidth seems to be at a premium at the moment. Sorry,
You got
I'll
it.
be back.
No problem. So let me try to adjust the video feeds in here because the screen will be scrambled. But yes, want to say, folks, the guests are the lifeblood of the channel. We do appreciate them more than you know. And they're all linked in the description box. So if you want to hear more, you can. Look at Dominic on screen. Look at his face there. Does that look like a guy you can trust? This is a great opportunity to find out by clicking on his link below. Dominic, wait a minute. Dominic, do you have a link?
Like some links on me. Actually, like you can find me on YouTube, Ether Cosmology, CZSK. So I'm actually like a part of the Ether Cosmology group.
You got it.
Did you say we're international, Dom? That's awesome.
Yeah, definitely. Ether Cosmology is international.
Shout
I
out
do
to
want
the
to remind you,
international
folks,
Czech lads.
if you haven't yet, hit that like button. We do appreciate your support of Modern Day Debate. It means more than you know. As I mentioned, the conference with Fight the Flat Earth and Austin Witsit Gets It. They'll be debating on different days. So they're not debating each other, but they will both be at the conference. Want you to check the link out. It's in the description box below right now. It's also pinned at the top of the chat. It is going to be 2 days of in-person debates in Newark, New Jersey, and you don't want to miss it. As well as you can see, there is a crowd fund for this event. Check that out. As, for example, you're like, James, what have you got in terms of perks? Like, what kind of cool things if I did donate to help make this conference become a reality? Here's an example. There is a signed emblem page. This is from last year. So this year it would say DebateCon 5, of course. Is you can get a signed emblem page from all of the speakers for that day, which is awesome. So, for example, on the Religion Debates Day, you have Fight the Flat Earth, a.k.a. Craig. You have Alex O'Connor. You have David Wood. You have Lawrence Krauss. All of those autographs will be on the page. Check out those cool perks at the Indiegogo link in the description box right now. Peter is back with us. Glad to have you back, Peter. We are ready for
I'm
your
back,
opening.
but I'm not
statement.
quite ready. I just saw that it was not helping the upload speed very much for me to not be here. So
Not a problem. Let's see here. What I'm going to do is just scramble these little videos on the screen, just because each time a person leaves the call, it scrambles the little guys here for me. But we're going to be off and running in just a moment. And I do want to say, folks, you might be thinking like, well, James, do you ship to anywhere around the world? Anywhere around MC Toon's precious globe? Why, yes, we do. If you were in Australia, so Flat Earth Aussie, if you were watching, or who else is in Australia that's like a Flat Earth or globe debater, by the way? Anybody know? Any?
What was the question?
Like, aren't there any other folks from Australia that are involved in the Flat Earth versus globe debates?
No, Australia's fake. Just like
Oh.
birds.
Paul from Plain Reality will debate anyone on the horizon.
Yeah, MC Toon. Yeah. Take that, Melvin.
He's
And
fake like birds are.
Hey guys,
Never-
I think my camera actually freezes, so I have to restart my camera. Sorry.
what happened?
My camera freeze. My camera is freezed.
Not a problem. But I've got to tell you this, folks. We're excited about the future as modern day debate is reaching new feats all the time. While you're waiting, this is a great time. A little intermission. We're like, okay, I got the Flat Earth opening. Just chilling now. Check out those links. And I'm even going to show you because maybe you're like, James, what do you mean about this conference? What are you talking about? I'll show you. If you look on screen right now, it's in the Northeast. So in Newark, New Jersey. Even if you were from Baltimore, just 2 hours and 45 minutes away. So if you're in the New York City or Philadelphia area, this is a piece of cake. Folks, you have to come to this conference. But not only that, you might be thinking, James, tell me what else there is at this conference. I'll show you with these epic posters. As I mentioned, it's a 2-day debate conference. On the left, you can see Lawrence Krauss, popular atheist speaker, against Mike Jones, inspiring philosophy, as well as Alex O'Connor versus David Wood, apostate prophet versus, I forgot to update that poster, Central Dawa will not be making it for the conference in any way, shape, or form. And you can see at the very bottom, Fight the Flat Earth, and Andrew Wilson will be debating. As well as Alex will be a slobber knocker, to be sure. Then, the next day, on the Sunday, February 16th, Political Debates Day, Not So Erudite versus Actual Justice Warrior on Trump versus Biden's policies. Alex Stein versus Andrew Wilson. Brianna Wu versus MC Toon's brother, Austin Whitsitt Gets It. No? Okay. And, but I got to tell you guys, wouldn't it be great? MC Toon, longtime debater on Modern Day Debate. Wouldn't it be great? MC Toon, you know, this is not our last DebateCon. DebateCon 5 is not our last one. I don't know if you'd ever have interest in in-person debate.
Sign me up.
Okay.
I'm there.
Because that's something that I'm like, hey, that could be pretty epic. Because actually, Whitsitt is the only flat Earth guy that we've ever had, or globe or flat. And then Craig is coming, although it's not for a flat Earth debate, it's for like a religion type debate. Although there's like a moon landing debate he'll be in. But MC Toon, you've been a longtime friend of the channel. And so I don't want to treat you like the redheaded stepchild that you are. We want to make you feel welcome. Okay?
Hey, Toon, can you open document format? I use LibreOffice.
Oh, certainly. Yeah.
Okay, awesome. Just checking.
In Google Docs. I might even have open doc. Let me see. I don't know if I have it.
While Melvin's looking that up, I will continue pitching. Folks, I've got to tell you, at this conference, it's going to blow your mind.
We've got a question from our chat, James.
Yeah, what's up?
People are wondering if we can see your subway tattoo.
Hey, that's a possibility. I'll be at the conference as well. I will be there in person. Let me know, by the way, really quick, because my mic the other day I had bad audio. Is my mic okay? I'm looking in the live chat. Let me know, folks, if I have like messed up audio like the other day. I think it's better this time.
You sound good.
Sounds okay to me.
Oh, good. Okay. But I've got to tell you, folks, you're kind of like, oh, James, can I see the subway tattoo? I got to tell you, you might see it. No, I'm not going to show it at the conference. That'd be weird. But it is real. And I've got to tell you, I've had enough Subway that I don't really want to have it ever again. It's I do love Subway. Very good, very convenient. There's one on every block. But I've got to tell you, for this event, you might be like, James, what do you mean about this like Newark location? It's at Holiday Inn. It's going to be in the Crystal Ballroom. It can hold up to 400 people. And no joke, we are shooting to max out those 400 seats. We're going for broke. But like I said, you're maybe like, James, but I don't know. It's probably like really far and stuff. I don't know about that. Believe me, it's not that far. If you're in New York City, it's only about 45 minutes. And you might be thinking, hey, well, James, like, what is it that you have there that, like, in terms of perks for the Indiegogo that is linked in the description box? As I mentioned, signed emblem page where you get signature from all of the debaters. Or if you want a signed photo, for example, if you would like a signed photo of Craig, Fight the Flat Earth, at the beach, shirtless in his European Speedo, this is your opportunity. You can get a signed photo of Craig. You can believe it that my dear friend MC Toon already purchased those up, though. There are none available. There's none left. There's none left anywhere. You know, I give MC Toon crap, but it's because I like him the most. It's like my love language. I like to tease people. And I just hope you know that, MC Toon. I know I call you Melvin. Now I'm accusing you of wanting to see Craig in a Speedo, but I want you to know it's all because I love you. Okay?
I believe you.
I think Toon has my presentation now. Is that right, Toon?
I do have the presentation.
I wouldn't have gone to so much trouble to save the presentation for here if I hadn't worked so hard on the slides. So thank you all for bearing with me.
All right, I'm going to share it, James.
I'll just say next slide when I want you to flip to the next slide. How's that sound?
That sounds good.
All right. Are we ready?
Yep.
I'm ready.
They're so clear.
All right. Next slide. We need to clarify the term flat earther. My opponents today, Alan and Dominique, next slide, are not flat earthers in the simplistic sense that might describe people from ancient cultures who made naive assumptions about the world prior to scientific knowledge becoming available. Next slide. Oh no, not at all. In today's world, as far as I'm aware, that type of flat earther does not exist anymore. I've never met one, and I'm willing to bet neither has anyone here. Quite the contrary. Next slide. Alan and Dominique are members of a very specific modern-day cult movement that I call Robothemism. Next slide. Because it started with Samuel Burley Robotham. Here it is right here. The first appearance of Alan and Dominique's ideology, the core of which is almost completely unchanged in the last 150 years. It remained in relative obscurity all that time until around 10 years ago when it started growing on social media through memes and conspiracy groups. Next slide. Consider the question, where did the sun go at night? Next slide. For 10,000 years, humanity has known the answer. Down, below the horizon. It's obvious. Next slide.
One sec. I'm just going to... 1 sec, I'm going to jump in and just turn your, if you could turn off your camera, because we had it going a little, it was going well audio-wise, but then it started to go bad the last like 10 or 15 seconds.
Okay, are we now?
Let's give it a shot.
Testing, 1, 2, 3, testing, 1, 2, 3.
That's still pretty bad, to be honest, but let's see. It's very, let's give it a shot now.
Was there anything that I said that was inaudible?
I honestly, we can't hear you. We might have to do this another night or something, because I just can't read your audio, and it's just, we're just not able to make out the words.
Oh boy.
Yeah, your bandwidth is very 1992.
I'm sorry, guys. I hope this isn't my fault. Hold on, I've got an idea.
Now it sounds better.
We can hear you now.
Confidence. If you're if you got anything running in the background, it might be worth even just every program shutting it. I mean, just in case it's like in some way using internet. I do want to remind folks, of course, Peter didn't know, he didn't know that it was going to happen tonight. So sometimes it happens. Mine actually, before we started, I had to like restart my PC. So, it happens. And let's see if Peter has an idea up his sleeve here as he tries to work this out. Want to remind you, but Peter and MC Toon are linked in the description box. And then Alan, I think you've got a link that I have to add there. Sorry about that, Alan. Do you have a link, Alan?
Yes, at space_audits on YouTube.
Okay, I'm going to throw that in the old description box right now as well. And then Dominic, I know you mentioned, actually, since Peter is getting that taken care of.
I had to step away for a moment to implement my iPad. I'm back now.
I sent it a link on our YouTube channel to the chat.
Okay, thank you. If you could email it to me though, that would be easier because that's how I do the description box on another computer, and then I've got the one that you just sent it to me to is like the streaming one. Email would be ideal. But Peter, are you able to give a difference there?
Am I able to what? I'm sorry.
Did you do anything different that would make it so that we could hear you?
Well, I don't know. It was a long shot. I tried to basically limit the other usage on my network, basically. But I don't think my network was the problem, so I don't know.
Let's give it a shot. It does sound a little better now, and we're just going to go until, if it seems bad, I'll interrupt, but maybe it is a little bit better. Go for it.
Okay, are we still live on your channel right now?
Yes.
Okay. And the audience can still see my slides.
Yes.
Yes,
Okay,
and I want to give huge props to the audience because we have 500 people here still waiting. So thank you for waiting, folks. Ready for you,
All right.
Peter.
All right, so Alan and Dominique are members of a very specific modern day cult movement that I call. Oh, I read that already. Yeah, so consider the question, where does the sun go at night? It goes down below the horizon. It's obvious. You'll notice this basic observational fact, next slide, is with both the globe and all ancient flat cosmologies. Next slide. And yes, I checked. It's all of them. Next slide. And yet, one day, Samuel Rowbotham decided out of the blue to throw out that answer and instead say, no, really, the sun moves away horizontally. It's an illusion due to perspective. Next slide. This will sound familiar to anyone who's dealt with a present-day Robothamists such as Alan and Dominique. They still repeat the exact same cult dogma today. Next slide. We Globers call it flurfspective because it makes a butchered, incoherent mess of perspective geometry. Next slide. An object's vertical position in your eye or camera lens is dictated by the inner angle of this right triangle. You'll notice that no matter how long you make the bottom leg of the triangle, it will never, ever, ever make that angle go negative, as we see the sun do every day. Perspective doesn't work that way, and any simpleton who can pass high school geometry should know better. Next slide. The sun goes up and down, but Alan and Dominique must deny that as part of their cult doctrine. They are sunset deniers. Next slide. The way an object can recede infinitely without ever crossing that zero line, next slide, is by following a non-linear pattern. It's like dividing the angle in half every time the distance doubles. Each time the position in your eye moves less than before, so the spacing in a time-lapse like this one is extremely variable. No two frames are the same distance apart because it's slowing down the whole time. Is this what the sun does? Next slide. No, not even close. I took a 3-hour time-lapse of sunset using 2 identical cameras, next slide, one with welding glass and one without, while I tracked the sun's position using a compass and sextant. Next slide. Oh boy. That looks weird, the way that's displaying. Anyway, we should be looking at a... Go to the next slide, I think. Yeah, that's the compass and sextant. Next slide. In the resulting time lapse, next slide, the spacing is fixed. It's the same distance between every pair of images. Next slide. That sun cannot be moving away from the camera due to perspective. This evidence makes that obvious. Next slide. So Alan and Dominique And Dominique, feel free to translate this message to your entire Czech audience for me too, if you'd be so kind. Let me be frank with you all for a moment. On top of being scientifically wrong and mathematically incoherent, your cult dogmas have no foundation in any other form of human thought. They sprang into existence out of nowhere, almost fully formed, but unlike Mormons or Muslims or Buddhists, you don't even have the self-awareness about that to say they came from God or an angel or something. Apparently, you think that Samuel Rowbotham was just randomly born one day as the only free thinker the world had ever seen, but he's not even a big enough deal to mention? Next slide. There's a reason your cult not only attracts but celebrates disreputables, malcontents, and unteachable dropouts. There's a reason that these conversations are basically internet bar fights instead of grown-up discourse on a real-world stage. Next slide. Your belief system is made of memes that are 5 years newer than Minecraft. Where did you think it came from? Next slide. While you were both what were you both doing in 2009 while I was comparing my lifelong biblically grounded young earth creationist beliefs against mainstream science at a college level, deeply exploring the apologetics of theology, anthropology, and how worldview does or doesn't affect science? Next slide. You don't get to fall in here backward, crash the party, then act like you got here first. Next slide. If you want to tickle your brain's limbic system with a pack of self-indulgent spy thriller fantasies where you roleplay as Morpheus, don't call it real and spread defamatory misinformation about Jews, astronauts, and Freemasons. If you want to be taken seriously, don't base your identity on preaching lies. Next slide. Robothamism is deliberate insanity, and I think any reasonable person is about to see that firsthand. I just presented a perfectly sound, bulletproof globe argument based in geometry and my personal measurements of sunset, but neither of you are going to even attempt a logical rebuttal. If you don't run from the topic entirely, I predict you will answer by playing semantic games, nitpicking random unimportant details, spewing word salad perspective, and inventing ad hoc rescuing devices. It's like perfect clockwork because you do not care about truth. It's all show, no substance, only brainwashed cult dogmas. Thank you.
Go straight to MC Toon. Thanks for being with us. MC Toon, the floor is all yours.
All right, give me a second. I got to stop his share. Start my share. All right, just a second.
If you haven't hit that like button, folks, we really do appreciate your support. If you would be willing to do a kind gesture today, that would mean a lot to me personally. Each like that I see gives me more satisfaction and pleasure. Here we go, MC Toon.
Pleasure. All right. Well, for over a decade, flat Earth robotomists have claimed that there is no 24-hour sun in Antarctica. They parroted Eric Dubay, who first said it in 2014. He borrowed it from Samuel Rowbotham, who invented the idea to fit his flat Earth map, knowing his Victorian audience would not question him, and Dubay repeated the lie without any evidence. Dubay knew his simpleton target market also wouldn't question him. All flat earthers that have ever made this claim are parroting Dubay, intentionally or not. It is flat earth religious doctrine. It is sacrosanct. Well, last month, I went to Antarctica with 4 flat earthers where they did see the 24-hour sun themselves. There was no military interference, no ice wall, and no restrictions. On the trip, we did a large number of experiments. Every single one matched globe predictions, and every single one falsified flat Earth. I'll cover a couple of these experiments. First, the very obvious test if the sun did circles as the globe predicts, or did whatever flat Earth predicted. Of course, it matched the globe, just as it has been reported for over a century, just as all the videos the flatties have blindly rejected for the last 10 years shows. There is a 24-hour circling sun, and it is completely impossible on all flat Earth maps. Even the Pac-Man maps don't support a 24-hour circling sun, like this one here. This is a Pac-Man map because if you're over on the west side and you want to go over to the east side, you have to magically teleport to the other side. They have problems with the non-Pac-Man edges too. Oh, yeah, there's another flat Earth map. But Either the oceans fall over the non-Pac-Man edges, spilling onto the turtle's back, or there must be some sort of a magical barrier. Of course, this is too much of a stretch for even the most simpleton of flat earthers. But maybe they just haven't figured out the map yet. Maybe there's just a few tweaks. Maybe there's just one more thing they need to do to figure it out. Well, let's test that. Here's a Rubik's Cube right here, right? You see how large that is in the screen, okay? Now I measured this ahead of time, right? It's about 3 times farther away from the camera. It appears smaller. When something is significantly farther away, it shrinks in angular size. When something is already far away and changes its distance by just a tiny percentage like this, it's imperceptible. Did you see that? You didn't. Elementary school children understand this, but do robotomists? Let's see. In Punta Arenas, I measured the angular size of the sun at local solar noon, and at 6 hours later by taking photographs with the Nikon P1000, the flat earther camera of choice. I'm going to present my screen again here in a second. I used a solar filter and properly exposed the photo. And this is it right here. You can tell that the photo is properly exposed because you can see the sunspots. Now, using the only map the flat earthers have ever seriously posited for the last 150 years and employing a 2-dimensional coordinate system, I applied perspective. And we can easily determine the straight line distance to the sun while postulating flat Earth. For brevity, I won't cover it now, but you can see all the math on my website at mctoon.net/TFE-experiments. So here again is the sun at local solar noon. The flat Earth straight line distance to the sun is 6,717 kilometers. Right? This is the photograph. Now, 6 hours later, the straight line distance is 21,075 kilometers. That's over 3 times farther away. Perspective requires that the sun is about 1/4 the angular size as it was at local solar noon, just like the Rubik's Cube I showed you. But what did we find? We found this photo taken 6 hours later. Noon, 6 hours later. So it's local solar noon. 6 hours later. You notice something? It's the same size. The sun did not change in angular size, even though for flat Earth, perspective absolutely requires it. It's using the same camera settings. It's the same sun size. This is not possible on flat Earth. But it gets worse. Being the same angular size requires that the sun must circle Punta Arenas on December 12 at the same distance all day. But flat earthers also claim that the sun gets lower in the sky because it gets farther away. They love to show photos of streetlights getting closer to the ground because the lights are farther away. But according to perspective, the sun did not get farther away. So it could not have appeared lower in the sky because perspective says the sun did not get farther away. But it gets worse. Flat earthers claim the sun sets because the sun is too far away, due to perspective. But perspective already chimed in and declared that the sun is not getting farther away, so the sun cannot set due to perspective. This is where flat earthers start to cough up excuses. They don't know what the sun is. Therefore, how can they know how it acts? Well, they knew it well enough when they were claiming the sun sets due to perspective. Not that you need to know what something is made of to apply the law of perspective. They'll also brag that they're unable to determine the shape of the ground by looking at things in the sky. And I completely agree. Flat earthers are not smart enough to determine the shape of the ground by looking at the sky. But children that successfully graduated middle school are smart enough. But it gets worse. In Antarctica, Dave McKeegan photographed the sun every minute for 24 hours. I'm sharing one more time here, James. Last one. It will surprise nobody to learn that the angular size of the sun did not change the entire 24 hours. So here it is. Here is 24 hours of photographs of the sun. not changing angular size. But it will surprise some flat earthers to note that the sun is actually rotating, showing that not only is the sun spherical, because you can see over on the left side, the sunspot, it's going off, it's getting compressed, it's going out of view, but it's very much a physical thing. So not knowing what it is not an excuse. Flat Earth has the same problem with the angular size of the sun as it does in Punta Arenas. It has to be the same distance from Antarctica the whole day. And that problem exists 24 hours a day, but it gets so much worse. All the normal people that went to Antarctica asked our audience to take photographs of the sun with solar filters on each of the days we were in Antarctica. We had an absolute flood of photographs. A volunteer by the name of What's Up curated these submissions on the flurf.info website. And I bring it up right now. Let's see here. So many photographs of sunspots. Here you go. Look at them. Pages and pages of them. You can peruse these yourself, and when you do, you will discover that every single photo shows the same angular size of the sun. Perspective is a relentless taskmaster. Perspective informs all of us that the sun cannot be small and local. It must be very far away, far enough away that many thousands of miles distance between the different photographers is a trivially small percentage difference to the total distance to the sun. This perfectly matches the globe and completely falsifies flat Earth. Again. Now watch, dear viewers, as the flat earthers spend the next couple hours desperately avoiding this topic. They will never provide any evidence-based methods by which this can happen. They will never provide a map where this works. Everything they will provide upon investigation will dead end at the same place, a faith-based claim. That's because the flat earth is a religious cult and it's dead.
Thank you very much for that opening MC tune. We are going to jump into the open dialogue. I was on mute again. Thank you very much for that opening MC tune. We're going to jump into the open dialogue, and thank you very much, folks, for watching. We'll have Q&A afterward. If you want to submit a question, you can do it in two ways. One, you can tag me with @ModernDayDebate in the live chat. Otherwise, you can send in a super chat. Well, that will push your question to the top of the list. With that, thank you very much, gentlemen. The floor is all yours.
All right, cool. So before I begin, I took some notes there to kind of give a broad spectrum reply to everything, and then we could go over the specifics and details. So to start us off with, there was a lot of slander, fallacies, ad homs, et cetera, et cetera. Not going to bother talking about those or addressing those.
Is this open discussion right now?
No, not yet. I'm doing a quick recap, and then we're going to get into it. So anyway.
If you want to do a quick recap in terms of just a few points, though, because like if it is, just to be a heads up, that it is, if it is too many minutes, it's kind of like it defeats the purpose of open dialogue. So maybe just a few points. Otherwise, it turns into rebuttal speeches.
Yep, gotcha. All right, cool. So redefining flat earther as robothism does nothing, right? The original premise was that you can't use objects in the sky to prove what the shape of the earth is, but you can prove what the shape isn't, right? Following the scientific method there. Now, it was stated that sunsets would be mutually exclusive on a globe to cause the physical obstruction to block light. Now, of course, there's light attenuation and
wait, I'm sorry. Alan is giving a rebuttal to our presentation. I thought this was a recap of his presentation, not a rebuttal to ours. We should be able to speak if he's giving a rebuttal to ours.
Peter, we'll give him just a minute or two.
Yeah. What you presented was.
I'll give you a chance, but I agreed. I mean, I did just tell him that we don't want it to go more than just a couple of minutes.
Face, James. You're a little close.
So what we'll do is we'll give him a couple of minutes, and by that I mean like we'll give you another 60 seconds, Dominic, and then we got to go into where they can actually respond.
Yeah, so this was my original presentation, like all the points that they brought up, right? Objects above the horizon don't prove the shape of the earth. So what we can get into each specific thing mentioned. So sunsets, Toon was saying that latitude dependent sunspots, all of these things, we're going to go over all of them explicitly, and it was stated that the sun has to be 93 million miles away, but we're going to go over how that's not the case for celestial navigation to work. So anyway, whenever you gentlemen are ready.
I'm ready.
This is open dialogue. They've been ready the whole time. Go ahead, gentlemen.
Okay, cool. So if sunsets truly prove a globe, there will be a
No, this is open dialogue. That you've already talked for like several minutes during open dialogue. Now we got to give somebody else a chance.
Oh, I was waiting, and nobody said anything. Go ahead.
As I said, you didn't address how the angular size of the sun can vary throughout the day using whatever you think the flat Earth explanation is.
Great. That's a good thing that you brought that up. That is in the notes, and that was covered in the Prezi at the beginning. So the sun and all celestial bodies are considered to be infinite light sources, and you could treat them that way in regards to the distances. So for celestial navigation specifically, you can treat everything at a distance of 6,218 miles away from you at the altitude. That's what they cosine to stars. So you can think of a celestial sphere in that way. So if everything is an apparent light source that's projected to us, and we see it in our field of vision, then it isn't a prediction.
Yeah, Alan,
that it would
that
change.
geometry works on a globe. It doesn't work on a flat Earth. So if you're just saying that it's a magical thing that we can't explain, then that doesn't help you.
Well, we have a hemisphere of vision, and we have two respective hemispheres that are mapped to the so-called globe that you think we live on. That's actually a spherical coordinate system. So this isn't mutually exclusive to either. Both have elevation angles to the stars and sun. That's
No,
what
the geometry works on a globe.
Say.
It doesn't work on a flat Earth.
Which
just show us the
geometry are you referring?
The flat Earth geometry. Show us the flat Earth geometry. How does the angle work on flat Earth to pick your celestial object? Show the map for it for different locations on the Earth.
Okay, 1 second. You want
not for the globe. I mean, you spoke at length about the massive success of the globe using spherical coordinate systems. I completely agree. You've not addressed how it works on flat Earth yet, though.
Well, it would be just the same elevation angles to stars, right? Because we're starting with Polaris. As you get further away, 69 miles per degree, if there's an optical equivalence, that's what my position is, through curved visual space, which I brought up in the original Prezi there when I talked about.
Yeah, what is that? Show us that geometry.
Can you stop interrupting, please?
Yeah.
I'm interrupting because he's not answering the question. He's just invoking magical terminology and not answering the question.
Well,
it's just faith-based here. Yeah. But as I said in my presentation, everything will dead end at faith.
Well,
so you said it's
some sort of an astronomy book from 1920 that went over the optical equivalence between the two. So you want specific math. They're telling you that they're identical.
All right, one sec, just to be sure that so we don't have everybody. I do want to. So I think Peter asked a question, or Peter said, but I'm looking for this particular thing, Alan. We'll give you a chance to answer that question. Peter, can you say it one more time? What was it that you were looking for from Alan?
I'm looking for the geometry of how he thinks that star zenith angles work on a flat Earth, because they work according to geometry on a globe. But he's just invoking magical phrases and saying, show us the geometry for how those magical phrases work.
All right, let's give him a chance. My guess is that you would disagree with that, Alan.
Yes. We have the exact same equivalence for optics. We have a radius of vision we see in a dome. When you compare what you see in the sky to the ground, they say that there's an equivalence there, but trust us, it's the ground that's curved. That's what I went over earlier in the beginning of the presentation with the citation from the astronomer book.
It's not trust us. That's not correct.
This isn't trust us, bro. It's a direct primary source documentation. Would you like me to read it aloud, sir?
If you think it'll answer the question, sure.
It absolutely does, and then we'll go over the math here in a second. So overhead is a dome of the heavens, which so far is determined by the actual positions of the visual bodies, like the heavenly orbs or the blue sky or the clouds, has in no reality a definable shape, but may be geometrically regarded as a hemisphere around its center. This is not indeed the natural idea of the observer, whom the dome of the heavens appears somewhat a flattened form, the horizon being between them 3 to 4 times away over the region overhead. Considering the cloudy sky, we have to remember that we must rightly understand what we see is usually the curved surface at which we look is much flatter than this. We mistakenly attribute the domed shape of the heavens, whereas in reality, the curvature is no greater than the curvature of Earth itself. So I'm saying that there's an optical equivalence there. You guys studied Robothamism. So what was Robotham's position about the curvature of your eye and optics in everyone mistaking the curvature of the ground for the measuring device that they're using?
That's not the core of Robothamism. The core of Robothamism is believing the sun stays above the earth 24/7, 365, which, if I'm not mistaken, you also believe. That makes you a Robothamist.
Can I ask like why we still bring up the Robotom? Because like for example, in Czech, Slovakia, and in our countries, we like don't care about the Robotom at all. And there was like some generations who believe in flat Earth cosmology before Robotom. So I like in China, for example, until 17th century, because like until Jesuits came to Asia, they believed that Earth is flat and stationary, and they have like dome up of their heads. So I don't think they knew Robotom.
Yeah, so
All right, lads.
Dominic, did you not hear my presentation? The
sorry.
sun, they believed the sun went below the flat earth. Those people were not Robothamists. You are a Robothamist because you don't believe the sun goes underneath the earth.
I don't
Do
think
you
this is a
believe the
definition of
sun goes-
robotism.
Yeah, I don't agree with the definition, and I don't care if you.
I don't
keep
care
using
if you agree with it or
doesn't-
not.
It
If you-
doesn't matter. You said you wanted to go over some geometry and math. Would you like to do that now, or what?
Yeah, I'd like to see the flat Earth geometry, not the globe geometry. If you use the radius of the globe, you're acknowledging that the Earth is a globe.
Oh, I'm using
You
the
don't
radius of
use
my
the
eye.
globe radius.
I'm
Your
using-
eye doesn't have a radius of
we
of
see
6,171 kilometers.
we
The
see in a
radius of
dome
your
vision.
eye is just a couple centimeters max. So that's that. You don't get to use the radius of the globe and pretend that it's flat Earth.
It's the radius of our vision, sir. That's what it is.
No,
This is
there's
how-
no
There's a
radius for
direct
vision.
equivalence. We just read it. We just read about the
Our
optical
Vision
equivalence.
is not a
Is no
physical
radius for
object.
vision.
It's a spherical space with no physical radius. It's incoherent to apply a linear measure to the radius of that sphere.
Well, we see in curved visual space in between 30 and 70
You'll need to
degrees. What-
support that
please-
claim.
Please don't interrupt. There is
You
a-
guys,
there's a
I
linear
assume
segment.
you guys can hear me in the Google call.
Mhm.
Okay, so when I jump in, that doesn't mean keep going. Like
Oh,
I'm
I
trying to bring
apologize.
order. So both you and Peter, if you hear me, that's basically me saying, "Hey, we're going to jump into 1 or 2 minute intervals." So let's give it a chance. Space, Alan, I should say, we'll give you a minute to respond. We got the timer set. Go ahead, and then we're going to do the same thing because there have been a lot of interruptions already. So go ahead for a minute, and then we'll kick it over to Peter for a minute.
Thank you, sir. What we're looking at is the optical limits of your vision defined by your optics. Now, we're going to start with the angle of elevation to Polaris, which decreases as one moves from the North Pole, right? This is what we're looking at over here. This is the same equivalence on a flat Earth or globe, right? Now, in radians, we convert that for the necessary conversion, which makes it a trigonometric function. We use the hypotenuse. On the globe, you would say that this represents the radius of the Earth. For the flat Earth model, this would just be the distance from the observer to a point directly below Polaris on Earth's surface. So that's the equivalence between the optics and the triangles that we're drawing. Because the cool thing about triangles, if they're in the sky or on the ground, it doesn't matter. You can do it either way. It's going to come out to be the same thing. And like I said, when we get into measurements of Earth curvature, there aren't any. Everything presented is against my null hypothesis has yet to falsify it. You guys have only presented explicitly things that are occurring above the horizon for observers, and then claiming that this is mutually exclusive to a globe so far. And we haven't even got to the geometric properties of shadow sets, which means that the globe isn't setting behind curvature, because objects casting shadows never cast them higher than the objects themselves. They actually raise up at 15 degree, or corresponding to that 15 degree per hour, and then they slow down as they would. Instead of going over the object casting it, they actually slow down,
We'll
and
jump.
then they fade out.
We'll switch it over to Peter for a minute.
Mm-hmm.
Okay, you still didn't answer the question, and you made a bunch of false statements. So, like the stars corresponding in a linear correlation to your latitude, that is exclusive to a globe, because on a globe, your orientation changes with latitude, and your orientation dictates the elevation of the star. It's a linear relationship because of the surface being a sphere. So if you are denying that geometry, then you have no explanation left for why that relationship is linear. If you're saying it's due to perspective, like Robotham said, then it makes no sense. But if you're just I should say it's mathematically wrong in that case. But instead, you're just, throwing around these phrases like we see in curved visual space. That doesn't answer how the geometry works.
Yeah. So specifically, we have a near field and a far field and an extreme far field. Those are broken up into 3 portions. As things are closer to you, that's more linear. As things get further away, the extremities of that curvature increases. Right? It can be best described as logarithmically. As I stated earlier, when you have elevation angles, so what we're looking at here is how the same thing would work on a flat Earth. Here's some geometry for you. So anyway, as everything for celestial navigation starts with about 30 to 75 degrees angle-wise, that's where you have the linear portions. The linear portions of your vision are going to be represented by that 69 mile per degree relationship. And outside of that is where you're going to have the most corrections. And when you look at the almanacs, that's what you'll find outside of those ranges. Now, what we're looking at here is the exact equivalence on a flat Earth for these angles. Oh, look. Where'd the globe go? The globe would just be representing things as a negative coordinate system as they go out of your field of vision. All you ever see is one hemisphere at a time.
All right, you've thrown out this assertion about curved visual space, things like that, with zero supporting evidence for it. So I'm going to just simply ignore it and ask you once again, can you provide the actual geometry? I can go over the geometry that you would need to go over. It's not that difficult. It's something that is covered in wrong one there. Here we go. All right.
Just so people are on the same page, Melvin, aka MC Toon, is currently sharing his screen.
Sorry, I got you.
All right, you see that there? All right, so here's your opportunity. This is where you do the actual geometry. Are you seeing this, right? So you've got, here's Polaris. You brought up Polaris. Here's the North Pole. Sits there nearly above the North Pole. Here I am in Minneapolis. I measure the angle to Polaris at 45 degrees in angular elevation. I am 5,000 kilometers from the North Pole. So now here we are at the equator. Okay. Now, show me the geometry, the application of geometry that predicts the angle to Polaris at the equator using flat Earth. What do we do here? What's next? I'm ready.
All right, give me 1 sec. Pull it up. There we go.
Baseless assertions are just faith-based cult dogma.
Did you hear me? I said, give me 1 second. I'm pulling it up.
I'm preparing the audience to hear about your dogma and doctrine that is just faith-based.
That's poisoning the well.
Sounds like you're poisoning the well there, Slick. All right, so here we go.
No, he's just making an observation.
Oh, is that what it is? Okay. So the angle is 60 degrees seconds. There. The hypotenuse distance to the star, 60 degrees. Cosine the ratio, adjacent over hypotenuse, equals 0.5 degrees. You can solve this adjacent side with the adjacent equals hypotenuse times the cosine, 60 degrees. The adjacent equals 60 times 0.5, which is 30 degrees. Using that relationship, the adjacent horizontal distance is 30 degrees to the position of the observer. Using the adjacent distance of 30 degrees, the conversion is 69 miles per degrees. Distance equals 30 degrees times 69.08 miles per degree, which comes out to be 2,072 miles. The distance along the Earth's surface is approximately 2,072. So this is the optical equivalence for what we're talking about. If we see in a radius and you think that you're calculating things based off of a radius and a deviation due to the contour of the Earth, there's an equivalence there. That's why my null hypothesis is that we can't use celestial bodies to determine what the shape is, only what it isn't, by the consequences of geometric properties like shadow sets and battle of the beams, etc. And
all right,
circumpolar orbits. Sorry, go ahead.
All right, thank you. You did not address this right here. You didn't use 45 degrees. You used 60 degrees. You said that this distance, something was 2,000, whatever. Here, equator, please. Geometry for equator using flat Earth, not globe. You don't get to use a radius of the globe, and you don't need to say anything about the globe. Show me how this works on flat Earth. Right here. This right
Alan, he just basically asked, what's 1 + 1? And you said red fish, blue fish, one fish, two fish is what just happened.
Is it? Or did I
So
calculate
that-
a distance based off of a triangle while you guys weren't paying attention?
You didn't
While-
answer
while
his question.
using-
You calculated
Okay,
a
so
random
all right, 1 second. Hold on a second. So MC Toon asked Alan. Well, let's put it this way. MC Toon is asking, "Are you able to do what he just asked you to do?"
No, I came with pre-prepared math just to show for that. I'm not.
No,
gonna-
no flat earther can do this. Thank you.
Okay.
Thank you. I said that you would not touch this. You are not touching the perspective, the application perspective. I know you can,
I brought
It was-
my own.
it
I
was-
brought my own angle and walked you through it 1-to-1, bro.
but that distance you got from the globe, that's the problem.
No,
You
it's
use
not.
you use the globe in that, because if you're saying there's that particular distance, right, it doesn't work on this particular geometry, which is what you're claiming. It only works on globe. The geometry you did was 100% globe only geometry, and you're like, hey, let me not really actually do flat earth geometry, hoodwink everybody into thinking that it was flat earth geometry, but it's not. Well, you didn't hoodwink the people that understand the topic, only the flat earth audience that you're trying to appease.
All celestial bodies are treated as an equidistant web at the same altitude to them. So,
Well, awesome. Then show how it's.
please, I just did. Don't ask
Let's
me to do
do
it
it.
again.
You
Now,
didn't
Let's
do
give
it.
them.
now
All right, we'll
second-
give.
Now,
All right, we'll give.
secondly-
Let's. Oh, just 1 sec. All right, we'll give Alan 60 seconds. Alan, the floor is yours.
What I already showed you is my angle for 60. Now, the units of measurement derived are a ratio of the terrestrial meridian, which I already covered is the distance from the North Pole to the equator at 6,218 miles. And then a meter is 1/10 millionth of that as the starting ratio. So any distances you get are going to be the same because we're using the same coordinate system and the same units of measurement derived from it, taking the same elevation angles to stars, which is not mutually exclusive to either model. You can do tangents all over a sphere and take the same measurements. You could do it on a flat Earth. The distinguishing factor here is when they went to go take zenith measurements of the stars and they realized that they couldn't complete the cosine relationship because the star was never in the predicted spot.
All right. Well, thank you very much for asserting and agreeing that you're using the same coordinate system. You used a spherical coordinate system. You need to use a non-spherical coordinate system. That's where the disconnect is. Everybody sees this here. This is the flat part. You need to use a flat coordinate system, a two-dimensional coordinate system, not a spherical coordinate system. Maybe you'd want to use a polar coordinate system, maybe a two-dimensional Cartesian coordinate system. But when you use a spherical coordinate system, you are admitting that the Earth is a globe.
Well, I understand that that's your position, and that's why I came up with the null hypothesis so we could independently verify the correct projection type, because the globe is a mere one of the many projections as I went over in the presentation, as well as the azimuthal map.
The globe is not a projection.
It's not a projection.
I'm familiar with the assertion.
So it's
That's not an assertion. That's a fact.
You use the spherical coordinate system.
What's
The globe is the sphere.
What's your
You
evidence?
you're my evidence. You used a spherical coordinate system. The globe is that coordinate system. You totally used it. You don't get to use the globe and say, "Oh, wink, wink, it's flat." You use the globe, dude.
Okay,
Thank
so one,
you
so
very
one
much.
second. So now the position isn't that you can take tangents to a sphere and do cosines that way. You're saying that this is now mutually exclusive when I agree
is
and
mutually
have the math to show it as well. Okay,
100% mutually exclusive. You use a spherical coordinate system. You need to use a non-spherical coordinate system. Good luck.
The only
It's your
system
path,
we
dude.
have is the
That's-
system that was given to us. Now, my position.
Then too bad you lost.
specifically- My position to start with, though, is that we only see in one hemisphere at a time. So if you map out the one hemisphere and you map out the other with the negative coordinates, you can combine the two to make the spherical coordinate system complete. And then you're using units of measurement derived from that spherical coordinate system. So when you cosine stars and traverse the land, guess what? It's always going to work out, and it has no relation to the shape of the ground. That's why you have to use things.
Oh, that's not
independently
true.
to
It does have
verify
no
it.
relation to the shape of the ground.
Well, not if there's an optical equivalence and we have a radius of vision that's the same as the supposed globe.
Well, you need
Yeah,
to.
not if
you
there's
need
a
to
magic
support
hand wave
Can I-
phrase that means nothing.
optical equivalence, blind faith religion.
Hey guys, can I interrupt for a second? Like,
Now, I want to hear about. I want to hear about the optical equivalence. Maybe you can explain it because he seems to.
well,
be avoiding it.
Alan actually like explain you and show you the math, and you just hand wave dismiss it. So
He used the
I-
globe.
He
Can
did
you
no
stop
such
right
thing. He
here?
actually
I-
admitted
I-
his
I-
input.
Second. I do.
Embrace.
Okay.
Guys,
Gentlemen,
you are
I do want to
interrupting.
give Dominic a chance. Hold it. Why, Dominic? When I'm talking, why do you
I'm sorry. I
give
just.
Dominic a chance? Dominic, what have you got?
Well, I would like you ask guys stop interrupting, stop using all the fallacies, because like in our presentation there were none, and I'm not here to attack you. I think we can like debate calmly without interrupting each other, and I think it would be nice. And if you like heard our position, we think if we try to like come to some conclusion, our position is that the Earth is planar and the measurement of the curvature are dependent on the position of the celestial bodies. That's our position. And so far, like in 30 minutes, you show us only like proofs that are dependent on the celestial bodies and looking up to the skies. And we think that if the Earth is a globe, then you should be able to measure the curvature independently on the celestial bodies, and that's our position. And if you have some evidence that is like mutually exclusive and it's only about the ground and not about the skies, then I think it's time to present it, because I heard so many ad hominem fallacies and stuff like that, and I'm not here for that, because I'm actually like searching the truth and I want to know the truth. And if Earth is a globe, I'm okay with that, but I would like to be shown some evidence and stop this slender fest. It's really not like, I don't like it.
There was
Let's
no
give it-
slander. There were no ad
We'll
homs
go
and
for a
there were no
minute.
fallacies on our side.
So we'll give it to Peter for 60 seconds. The floor is yours.
There was no slander from our side. You're simply mistaken. If there was something that you felt was insulting, it was an observation that is true. So I mean, we could discuss that separately. That's not really the topic for tonight. But observations of the sun and stars are perfectly valid. You guys are throwing that out for no reason. And the curvature of the Earth can be measured without them. There are plenty of ways to do that. That it's just a little bit more difficult, especially a little more difficult for flat earthers to understand typically, and that's why Toon and I didn't bring that particular evidence for our opening presentations. But you don't have a reason for throwing out the sky measurements. Your reason for like accepting them as part of your flat Earth ideology is just a magical rescuing device. It has no bearing. It has no correspondence to any geometry. And Alan actually admitted a minute ago. Am I mistaken on this, Toon? Like, did he admit that he doesn't know how to do the math that you asked him to do?
Yes,
He's just memorized scripts for
100%.
certain measurements.
But he also admitted that he has to
60
use
seconds.
the-
So before we do
Yes.
have MC Toon, we'll have 60 seconds from one of our guests
Can I-
from the Flat Earth.
Yeah.
Dominic, my guess is you want to say something, and then I promise we'll come to you, MC Toon.
Like I asked you to not use Adam and fallacy, and you still trying to compare flat earthers to like some dumb people who don't know anything. I think it's not necessary. And I ask again, like if the Earth is a globe, then there should be some mutually exclusive evidence that is based on the measuring the ground and not the measuring the skies. Okay, and if even like there's a just I give you the benefit of doubt that Alan doesn't understand anything about the math and geometry. And does it make Earth a globe if Alan doesn't understand it? Yeah.
No,
Okay.
it's
Then.
still a globe. Yeah.
Then okay. Then this is everything I need to know.
All right. Well, Dominic, I will use whatever I want to establish the shape of the Earth. You don't get to boss me around on what particular thing I'm going to use. So the angular size of the sun, that does not change. I said earlier, you would spend the rest of this time avoiding talking about it. Neither of you have talked about it. So I'm going to press one more time. Why is it that the angular size of the sun doesn't change? How does that that work on flat Earth without going to just faith-based claims?
Yeah, so I covered this earlier, but we can go ahead and recap it again. The angular size changing isn't a prediction on a flat Earth. I don't know any flat earthers that say that the sun is a physical object. All we ever see in both models is an apparent object. You think that there's a delay for the physical object of the sun, but what you're seeing is, the representation after the fact or whatever, right? Based on a distance of 93 million miles. Now, what our position is that it's an apparent object and it arcs across our field of vision, and that's what we see. And that's the part of the manuals that I showed you at the beginning for the solar panel thing. So this isn't a magical claim that's made up. This is a thing in both of our models. I'm just arguing that the physicality of the sun that you believe in isn't even necessary because of the relationship of celestial navigation and setting everything at an equidistant web of 6,218 miles away, which is specifically why I brought the math that I did. And now, secondly, I did agree that I couldn't do the math that you were asking me to do right then. And what I did bring was what you were asking me with a different angle. So to reject it and act like it wasn't correct or valid is kind of disingenuous on the face of it. And then on top of that, Peter keeps saying that we're throwing out the measurements. We're not throwing it out. We agree it's part of our premise, right? Your conclusion is our premise actually, which is kind of weird. And as Dom stated about a default position earlier, right? Optically, the curvature over an equidistant or equilateral triangle of 1 kilometer is 0.002 arc seconds. The Earth is perceptibly flat. That's why we're looking for independent measurements of curvature, independent of the positions of celestial bodies, because that's all that there ever is. And if you hinge everything on that, you can't even acknowledge basic things like perspective and curved visual space.
Well, thank
All
you
that
very
there
much.
ever is that you acknowledge
proving
is
us
just
right.
the easiest thing to measure.
I just want to press this. You said, "Oh, we don't claim that." I don't care what you claim. The sun definitely is a physical object. People can see that. People can confirm it. People can purchase for not a lot of money a solar filter, and they can replicate the same thing that Dave did any day of the year, that they can see the sun and see that it's got sunspots and that the sunspots move and that the sun is a three-dimensional physical object that's a sphere. So you have the burden still to explain how it's a consistent size regardless of the time of day or the location. You have again made an assertion that is a faith-based assertion, and you've proved me right again. I thank you very much for that.
Okay.
Can
Oh, go ahead, Dom.
You said that the sun is a physical object just by looking at it, that that's a physical object. How do you know just from looking at the sky with sun filter that is physical object? I would like to know because that's something I don't know.
What do you think it is when he showed you the picture with the sunspots?
And real quick, before you answer, I don't disagree about the sunspot orientation and axis of rotation or anything like that, and how it definitely looks like an orb in the sky for sure. My position, though, right, remember, is that it's an apparent object that we see. Everyone sees their own one. That's why when you triangulate it, the angles don't match up unless you set it to an infinitely far distance. But you can treat it as 6,218 miles away, the same as you do 93 million miles. There's no distinguishing difference there. Continue, sir.
So yeah, for the purposes of that, you can treat it like that. But for other purposes, you need to treat it as its actual distance.
What other purposes supersede actual land navigation?
Sending the Parker Solar Probe to orbit the sun.
That would be done with the Berry Center, which uses ECI coordinates as the baseline. So it's derived from the lab frame, as you would call it, and then calculated based off of positions of the celestial bodies. That's not it. Even if we grant you that premise, doesn't help.
They're not using ECI coordinates to send the Parker Solar Probe to orbit the sun. They're using
No, I got you, but there's no observer on the sun. And when you do the calculations for what you're talking about, you would use the Berry Center, right? That's what I'm saying. The Berry Center is derived from the geocentric perspective.
But you need to know the distance. You need to know the accurate distance. So yes, that's one way you definitely need to know the accurate distance between the Earth and the sun.
Yes, if you grant the premise of space travel, et cetera, yeah, then sure. You would have to do those calculations. I agree.
There you go. Answered. So now I'm still wondering, just saying it's an apparent thing is a faith-based claim to hand-wave dismiss the necessity of the very inconvenient thing that the sun's angular size doesn't change for you. And it doesn't work on flat Earth.
Well, we see like crepuscular and anti-crepuscular rays. So we like know that we see sun in apparent position on skies. And I would like to, because our position is that that the Earth curve, like the physical Earth curve, is equivalent to our like eyes and how we like proceed with the optics. So Alan showed you the math, and our position is that we should be able, if Earth is globe, measure it on the ground or provide some mutually exclusive evidence. And we did bring some mutually exclusive evidence in our presentation. And I would be like, if you had some answer on the Battle of the Beams, because I knew that you should be like new about this topic, because I think this is one of the best positions. And this is like a reason why so many people, even like in Europe, are actually like believing that the Earth is flat, because there's evidence that you can propagate there's evidence that they did propagate horizontal radio waves during World War II. And like there's so many like geometric mutually exclusive evidence that it would be impossible to propagate it on the globe Earth. And if we want to like move, this should be like a perfect evidence that we should like explain. And I think it would be really nice, because I think that there's so many people in Czech and Slovakia and Europe that is watching you, like you, Mektoon, for example. So it would be like amazing if you could answer it, because I think that you are doing here. This is why are you doing it? It's because you want to bring truth to the people and show them that we are mistaken, which is I think it's fine. So if you have like some claims or anything that you could say why Battle of the Beams, the propagation could be possible on the Earth if it's globe, then it would be amazing. Thank you.
All right. Well, thank you for proving me right. I love being right. So you have asserted that it's impossible on the globe without evidence. So I will just simply respond with, it's completely possible on the globe. There you go.
I asked you really nicely if you could like explain it, because we show you the evidence, we can share the screen and show you the math. I think like Alan have everything prepared, so it could be like amazing if we go through it, because for me, I don't actually, maybe you don't believe it, but for me it's really hard to be flat earther, because this debate for me, like example this one, is really new for me, and like your both presentation were Slenderfest against us, like so many fallacies and stuff like that. And I'm not here for that. I'm not here to be like insult and stuff like that. I would like to know some explanations for this evidence, because this is the evidence that is making so many people to believe in the flat earth, which is something I think you should be worried about, and you can do something about it. So it's not like I'm trying to win debate or something like that. I'm actually looking for the truth, and I think you are doing the same. So we should be able to discuss this evidence. It's one of the best.
Boy, none of that was a presentation to support your claims. You're just reasserting. I mean, you totally hogged all of Alan's time. But Alan, go ahead.
Thank you, sir. So what we have here is two overlapping beams that create a coherent tone in the signal in the center called an equisignal. The left of the center will be noted by dashes, and the right will be noted by dots. When they intersect, you hear a coherent tone. So this radar system was used to propagate out horizontally, where at 19,000 feet, the beam geometry that a pilot would fly through would be intersected by another beam using a slightly lower frequency. So when you hear the two tones, you would know that you're over target, and this would go on for hundreds of miles. Actually, it was noted by the Germans who built the system that at 13,000 feet, at 1,000 kilometers, the beam divergence was less than a degree. So it was completely accurate and not being diffracted or accounting for refraction or anything like that. And because the thing with this radar system is if the beam diffracts, the geometry needed to create the equisignal is lost, and it'll create pseudo signals and gaps in between it, and it'll be completely ruined. You wouldn't be able to use it to fly a bomber at 19,000 feet through the air over target. Now, the thing that makes this mutually exclusive here is that it's using the latitude longitude coordinate system to dial in targets and the locations of the towers. Now, when you math out what the predictions are for Earth curvature, the radar system should hit Earth curvature at about 50 miles. But what ends up happening is that it goes for hundreds of miles. So, for example, according to the official narrative, the beam was measured with a divergence of 500 yards at the equisignal at 270 miles. And this would only be, it was 50 miles shy of the Derby site measured at Spalding. And it was at, 400 yards wide. And that geometry is impossible on a globe because you hit Earth curvature at 30 to 50 miles, which would destroy the geometry. It would be completely useless. The only argument you could make is that it follows a tangent to the sky, which would place the beam 38,000 feet in this instance over target, which creates a deficit in the equisignal of 18,000 feet, which means that the beam would have to be like 3 miles wide to be used, and that's not what was measured by the British. And we have all the angles and everything for all of that. If you want to respond, I know I've been talking for a minute. If there's anything you want to cover.
All right. Well, I'll show you a little bit here.
So screen share?
Yeah, I'm just doing my camera here. For reference, this is the book that I used while I was at university studying electrical engineering. So this topic is something that I'm rather familiar with, though I haven't chosen it as my career.
Is there something you wanted to show MC Toon on your screen?
Yeah, do you see my camera?
Yep.
Let me.
Yeah, we can see.
Yeah, I'm just showing the book that I use in school. So it's just to show that this is a topic I'm familiar with. So you're not going to snow me on this, right? Anyway, so yeah, you got it right in the diagram there. It's a pretty good diagram. A little more. This was a little more simplified. It shows the overlapping of the beams there. You said it's not possible with diffraction. I don't know why it would not be possible with diffraction. It makes no sense at all for you to claim that. So for people that wonder what's that about. So when radio waves propagate through air, they don't need to be coherent, like when you look at things, in order for the receiving signal to receive them. What I mean by that is, if you look through a space where there's a lot of messing with the optics, you'll see just a blurry mess. But radio signals are not like that. You don't need to have a coherent signal. So when the beams were being projected here from the source, they were highly polarized, making them very easy to diffract off of the surface of the Earth. And they are also extremely powerful, super, super powerful. You would not be able to do this type of thing using FCC rules or Ofcom rules today. Or ICNIRP, as they sometimes say in England, in Europe. So there's no problem with propagating the signals that far, diffracting off of the surface of the Earth. And since they're already starting out highly polarized, diffracted waves are highly polarized, there's nothing wrong with what's going to happen there. I don't know why you're making such claims.
Okay, so to start us off with, it wouldn't be possible because of the starting and ending elevation angles based off of the Sagitta. So starting off of 656 feet for the altitude of all the radio towers. That's what we set it to arbitrarily to give maximum benefit of the globe. Through the historic records, no height of or elevation was like above 400 feet above sea level. So we added 200 to the top of that. And then anyway, when you calculate all that out, you're going to hit Earth curvature at 30 to 50 miles, which completely destroys your ability to use it. Now, you said that it would diffract around and reflect up, but that's not the purpose of the system right here, because remember, the dipole alignment that's doing the polarizing is specifically adjustable so that you could adjust the width of the equisignal over targets at different distances. This wouldn't be possible if the beam was physically obstructed by Earth curvature, because the diffraction pattern, as it would recombine out and fan out, would destroy the symmetry in it. The beam was actually so easy to spoof by the British that they just sent out a similar signal, and it would cause pseudo equisignals in it. So as I said earlier, to preserve the beam geometry, this has to be a clear straight shot line of sight all the way to target.
So you've basically said that it's not possible to be diffraction. That's it. That's all you've done is you've said diffraction wouldn't work.
I could provide
He said it why. He said it why. He said you why, because the geometry of the beam, it couldn't be maintained if it was diffraction from the Earth's curvature. If it was like diffraction from the Earth's curvature, then the geometry of the beam wouldn't be the same, like on the target that they are focusing over like 500 miles. So they propagating like a beam on over 500 miles, and they're mechanically, precisely tightening the gears to focus the dipoles to have a specific like beam geometry, which is impossible maintain if it was diffraction. And I actually spoke about this topic with radio specialist or amateur or whatever his name. And he's like more than 30 years in his like work, and he was actually like confirming every single point of this. So like to maintain the geometry of the beam, there's impossible to be like diffracted because the geometry wouldn't be the same, and they wouldn't be able to drop the bomb on the target with such a precision during the night.
Well, they weren't very precise, but so all you've done is reasserted the same thing. Thank you very much for your faith-based argument.
It's now time to answer, actually.
Yeah, so again, specific explanation was given, but we'll go over some additional stuff too. So in order to get authorization, because they were at wartime, to allocate resources to finding these beams, because a series of circumstantial evidence led R.V. Jones to believe that there was a radar system that, that had defeated Earth curvature and could be used against them. So anyway, he turned to his boy, Professor Eckersley, who was a radio propagation expert at the time in the 30s. He worked for Marconi, and it was part of the experiment that Marconi did with the long distance radio propagation. But anyway, he asked Eckersley to do some calculations for him to show how this would be possible on a globe, because everybody was denying that it would be possible. So that he wouldn't even get access to get authorization. So, but if he could show calculations, then, it'd be more plausible. Anyway, Eckersley, staking his professional reputation on it, did some napkin calculations that R.V. Jones went to go turn in. And the day that he went to go to the meeting to use the calculations, Eckersley said, "Hey man, I need to withdraw these because no serious professional would put these calculations forward." And they actually never show what calculations he did put forward or attach any specific mechanism, refraction or diffraction, to what he would have even have calculated. Now, he does have 2 publicly available papers that are published, but they're on omnidirectional radio wave propagation, basically, using sky bouncing and stuff like that in regards to what's called the heavy side layer and like long distances between like London and New York and stuff like that.
I didn't talk about the heavy side layer. I was talking about diffraction, and you've just reasserted that diffraction wouldn't work. And I remember you had some pictures up of the actual antennas. They're highly polarized, very well suited to diffracting.
Yes,
but then the geometry beam wouldn't be the same.
Yeah, the beam geometry. This is the distinguishing factor here.
I don't share your religious faith belief in that.
It's not religion faith. It's like even you can ask any radio specialist and he will tell you the same. He will tell you the same. I don't think you are a radio specialist because you have a book in your hand. Actually,
I have more background than you. So I'll ask me.
How do you know?
You on the top.
How do you know?
Do you understand?
You're disconcerting. You can ask anybody. I'll ask me. I am the person you were just speaking of.
Fair enough.
More than you are, Dominic. So you say, "Oh, the geometry." You didn't provide the geometry. You didn't provide the analysis. You didn't name the person that you're talking about that did, and then show the actual work that they did, showing that diffraction wouldn't work on a highly polarized signal.
Well,
did you listen, Alan?
Why should I believe your faith?
Did you listen right now, Alan? He told you everything and he showed you everything. We can show you again. It's okay. Yeah. I think the people who are listening us, I think that people are listening us, it will be like nice for them to see it again, because I think it's a great evidence. And like where you are acting, you are showing that you don't have any.
Hold on one second, gentlemen. Hold on 1 second. Just chill, you guys, gentlemen. I need you to first, when you guys are going to share your screen, it's helpful because basically I'm looking at OBS. Gotcha. And so if you can announce when you're going to do it, because it scrambles the screen on me, and also it'll let the audience know whose screen they're all of a sudden seeing. Otherwise, I have to interrupt you and say, so basically, first,
No
Who?
worries.
Okay, no, now nobody's sharing. Okay,
Oh no, sorry.
go
I knew-
ahead.
I
We'll
knew
give you
it
a
was
chance to
messing up your
wrap up,
thing.
Dominic.
Sorry, you're good.
Okay, can you wait until I
Well,
finish my sentence to start talking? Who was it? Alan, were you saying something?
Yeah, sorry. I took off the screen share because I knew it was messing up your thing, so I fixed it or put it back for
Okay,
you.
Dominic, I think you were saying something. Go ahead.
It's okay. I would like to say that we show the evidence, we show the math, we show the like technical specification, and everything that we heard that is like it's only our claim or our assertion, our religion. We actually show everything, and I think it's not necessary to insult us or hand wave dismissal our evidence, and just show us where we are actually wrong. Show us how it could work on globe Earth, and then we can like move on. But you didn't show us anything, and you just like keep attacking on me or Anna or Alan or our like credentiality, which is not the way to go, I think.
Yeah, I'll gladly answer the question. They are highly polarized antennas transmitting very high power that is well suited, very well suited to diffraction over the surface of the Earth. This is a topic that engineers understand very well today. It was state of the art in the 30s. It's not anymore. This is normal stuff that people understand well. There's no question. There's no people that wonder, well, I wonder how. No, this is the diffraction of highly polarized beams doesn't scatter. They stay polarized. They stay coherent like that.
Can I respond? So,
That's why we're having a debate. Yes.
Actually, when you propagate, you have to the dipoles on the antenna. You have to gear them on specific way. If you like gonna propagate on 500 miles, the dipoles will be on like some setup, and when you're gonna propagate on 700 miles, the dipole gonna be in different setup. So you actually have to maintain the setup on specific way to maintain the geometry of the beam that in the beam actually, and this is the problem because I think you are thinking only on the way how to like get the beam to the distance that we are saying, but the issue is that you have to get two beams on the distance, they have to cross over, and one plane have to fly in the beam and drop the bomb, which is I don't heard any like a claim that would be possible because you are saying diffraction, and if it's diffraction, then the beam is not gonna be in the same way if it's a propagation, like if it's only line of sight. So if you're gonna propagate it on the line of sight, you have to set up the beam, the dipoles on the some way. And if there's gonna be diffraction, then it's gonna be different the geometry of the beam. This is our position, and we are not answering on this claim.
Oh, interesting. So what is the difference in line of sight versus geometry? Be very specific because you are very specific in your claim.
Would you like me to pull it up for you? I can screen share. James, may I screen share?
Yes.
Sir? Okay. So we're here looking at 400 yards for the equisignal. That geometry that Dom is talking about has to be preserved because this is a line of sight targeting system. You mentioned earlier that, you know, it's common for radio propagation, you know, nowadays, et cetera. This isn't a huge technological feat. That would be true if this were in regards to omnidirectional radio propagation, right? But this is a coherent beam that's focused out of a specific dipole alignment that enables you to adjust it over distances so that you can hit targets. So we're starting with, let's see, starting with the geometry that it was measured at over target. So this is distances away from the target. I'm sorry, this is away from the radar system over target, where the equisignal has a geometry of 400 to 600 yards, depending on the distances, and that would be at 300 and 450 miles, respectively. Now, that geometry would not be preserved if there was Earth curvature because of diffraction. The beam divergence would be different, number one, and two, it would create pseudo equisignals when it would bounce up and recombine. Now, the fact that it doesn't do that is indicative of how the system works because of the beam geometry that was measured over target. Now, I stated earlier that Eckersley withdrew his calculations, and we have no actual reference to what they are. I did reach out to one of the authors on Twitter of the historical narrative of the Battle of the Beams, and he said, quote, I've seen the calculations, but I don't have them right now. I'll go get them. And then he said, well, it's definitely just refraction. You know, you're a flat earther, blah, blah, blah. Right. So he actually never provided any primary source documentation of what he, you know, of these assumed calculations anyway that were withdrawn. Now, what I provided here was the type of work that Eckersley was doing and how it's not analogous to the radar system, thus why he withdrew his calculations, because this is, as you were showing, omnidirectional propagation. That doesn't matter if there's an overlapping coherent signal that has to be preserved at 19,000 feet. Now, the most important thing to note here, right, is the angles of divergence between, the angle between the radar system and the plane over target is the arctan of that is less than 1 degree over pretty much any distance. Now, what we're looking at here is the horizontal propagation at some distance at where the beam diverges to 3 degrees above the horizon. We're way back here at 19,000 feet, sub 1 degree from radar system to target plane over target. So this is mutually exclusive to a flat Earth, because otherwise the physical Earth's curvature would obstruct the radar system and make it completely useless.
You haven't supported the claim about how it would be specifically different if they were going to direct the signals intentionally to be diffracted versus intentionally to be not diffracted. That was Dominic's claim. You didn't touch that.
Well, actually, that wasn't my claim. And actually, are you asserting that this war technology that were used for almost a year, that was based on propagating and counting out diffraction, that they propagated for over a year, bombing at the night from the antenna that is like a length of 100 meters, and they were counting on diffraction, that they were able to count 2 beams, that they were able to cross over and count the diffraction, and like that they were propagating and hoping that it would be like a good atmospheric condition and everything work out to be able to propagate it. I think if it's war technology, then you have to be like able to use it every single day and not to be counting on some random events or something that you cannot control. If it's war technology, then you have to be able to use it every single day and count on its precision.
All right. I don't know what their intentions were. Your assertion was that it was specifically different geometry if they're going to use diffraction or not diffraction. And now you've dropped that. I appreciate that. So now back to
we specifically addressed it.
But let me finish. Back to your original claim where you said for some reason that these highly polarized signals could not diffract. I'm just still waiting for that. You said we have nothing from Eckersley. Okay, fine. You didn't bring up anything from the Germans on this topic. Okay, fine. So far, it's just blind faith belief that you could not do diffraction.
Okay, so I'm going to explain this again, so pay attention carefully, because this will be the 3rd or 4th time. The equisignal, right, the thing that the plane flies through, has a certain dimension to it over distance due to the natural beam divergence, right? Okay, if there's diffraction, if the signal gets ruined, if it gets split, if it starts reflecting, it's going to create pseudo equisignals at different points where the dots and dashes overlap. It would ruin the coherency of the system. That's exactly how it was countered by the British when they were sending signals in of a similar frequency, and it created pseudo equisignals. This is a line of sight radar system. It was specifically stated by the British that this system would not work because it requires that specific geometry of the overlap signal to naturally diverge and be adjustable over different targets, because you're going to be at different distances, so you have to change your dipole alignment. All of that would be physically meaningless if there was a physical obstruction of curvature between it. So the answer to your question again is that the equisignal would be completely useless. So you wouldn't have that clean beam geometry at 300 to 400 miles over target where the divergence is less than a degree on the equisignal.
Okay. All you did was reassert the same assertion the 3rd time. You didn't yet provide claims. You said, let me say it, it would be this way if it was diffraction, but you didn't support the claim.
I
I
think we've
actually,
reached the peak on this.
yeah, we show you everything. We show you how the beam looks like. We show you
I agree
information.
with it. I agree with all of
Can
it.
you please stop
I
interrupting
don't
me? I let
disagree with any of it.
you speak all the time. I never
my God.
interrupt you.
One sec. All right, gentlemen, take a deep breath.
Slap
Hold
your
on a
face,
second.
buddy.
All right, we're gonna give 60 seconds to Dominic, and then we'll jump right back to you, MC Toon. I think Peter is still here. Peter, are you still here? We can't see you.
Yes, I am.
Okay, he's still here. Okay, go ahead, Dominic.
Yeah, it's just not time to insult flat earthers, I guess. We give you like evidence. We give you how the beam looks like. We give you the way how it's work. We show you evidence from the German. We show you like how the beam width or length over the distance where they're dropping the bombs, and we gave you like. Everything that you need, and you didn't answer any single thing, and you always like stay handwave dismissal it, and then you start ask question. And I know that you have been debating a lot, but this is not actually like a battle against each other, but we are trying to show you the evidence that why so many people are flat earthers right now. And you could like give us some answer on Alan's specificity, and if you can't, it's okay, but then you don't have an answer, and this is the reason why we are flat earthers. And my camera free, so I will rejoin 1 second. Sorry.
All right. Well, I did give an answer. You didn't like it. In response to my answer, you made blind faith assertions multiple times and refused to support your claims. I completely agree with all of the things you talked about, the shape of the beam, and the divergence, and the angles, all that. No problems with that. And I'm saying a highly polarized beam has no problem diffracting and staying coherent after diffraction. And you say, nuh-uh, without any evidence for that.
Can you steel man my position before we move forward?
Nah, I don't care. Don't care. Yeah, your position is magic. There's no steel manning. It's magic. You just assert that if it diffracts, it will scatter in all directions. That's not necessarily how diffraction works.
Alan, in all truth, the best steel man that we can produce would be just that you don't understand what Michael Toon is saying. That's the best steel man we can create.
Well,
It's that incoherent.
that's a
your
completely
argument.
useless comment to the conversation. If you would like to add a refutation to it, you're welcome to do so. But if your sole contribution is to do that, just go ahead and turn your mic back
I
on
was
so mute
replying to your question about steel manning you.
Peter, actually, everything that you did in this debate so far is only insulting us and creating new ad hominem fallacies, which is insane. Like, if you say that Steelman is that we don't understand it, it's such a... Please don't interrupt.
Just one 60 seconds at a time. If you want
like,
to finish, Dominic, go ahead.
Yeah. Just say that Steelman, our position is that we don't understand it. I just told you that for me it was such a like cognitive dissonance evidence that I actually went to the radio specialist and I asked them because they were neutral. They didn't care about the shape of the Earth. I just asked them how the beams could work, how the specificity of the horizontal radio propagation and stuff like that. And everyone who look at it is gonna say, "Wow, this is something I don't understand how it could be propagated on the globe." And it was actually the position of the British. They were not able to understand how the German could propagate the beam over the distance if the Earth is globe. So like it was even the British position. And like if you have some refutation on this, it would be really nice.
Gave it to you.
Insulting
Stop
us.
asking for it again. I already gave you the reputation.
You didn't give.
Hold on.
You didn't give
We'll
us
give
anything.
just a little bit, 10 or 15 seconds here to wrap up, Dominic, and then we'll kick it back over.
Oh, you just you can give him the space. I would like to hear some refutation, and the refutation it's not gonna be the beam is so strong that it's not gonna change the coherency and the geometry if it's gonna be diffracted. It's a basic thing about radio waves. Is if it's gonna hit some physical obstruction, it's gonna diffract. It's not gonna maintain the same geometry of the beam. It's so simple.
Dom, can I call you Dom?
You started calling me Dom without asking, so it's fine now.
Well, that's the first time I've called you that.
Nope,
That's
it's
why
not.
I asked.
For the crying, just
Yes,
call
it
him
is.
dumb and just make your point.
Do you look at your own face in the mirror sometimes?
If you're gonna follow if any like flat earth insult or anything like that, I'm not gonna respond. I don't like it
I'm
anymore.
not trying to insult you. It's an honest question that will help illustrate a concept about how wave propagation works. Do you look at your own face in the mirror sometimes?
Yeah, I do.
Does it still look like your face when you look at the reflection in the mirror?
It depends on the day. If I have like a hard morning, I look like a shit, to be honest.
Well, I'm sure that we all have those days, but the point is, certain systems can alter the path of a wave, whether that be a light wave or a radio wave, without decohering the image. So it still looks coherent after the path has been altered. That's what Michael Toon is saying happened here. If I understand you right, Michael, am I understanding correctly?
Yeah,
He's saying the path was
angle it. Yeah.
It's not the same as a reflection, it's diffraction instead, which is also not the same as refraction. Some flat earthers get those mixed up.
And
This
it's
is
not-
diffraction.
And here we go. And here we go. You were able to maintain it for like 54 seconds
Oh, cry
until you
hard,
claim
little
again
boy.
flat earther.
Oh my gosh.
Dominic, that was not an ad hom. That was an honest statement. I have literally heard flat earthers mix those up. That's why I clarified. I was simply telling you why I was making the clarification. I was not trying to insult anyone. I'm trying to say that diffraction will alter the path of the signal being propagated without decohering the signal. It still has the same shape as it propagates. It's just changed path.
Did you try this with a mirror globe? If this is your comparison, if you make a mirror globe,
Listen.
it's gonna work.
Lads, do you guys want to know why that's physically impossible? Right? There's Earth curvature, supposedly, in between the radar system and the target. You have to overcome that. You're not bouncing over top of it. You're only, at maximum benefit of the doubt, 700 feet above sea level. Right? You are hitting Earth curvature, there's no like
That is
you would be
Earth
following
curvature is
you would be following a tangent to the sky to preserve the beam geometry. That would be your only that would be your only option. Now, this is
Not
important.
my claim.
This isn't, well, it might not be your claim, but this is important because in the historical narrative, there is no proposed mechanism, diffraction or refraction. Because when you attach the math to it, none of it works out. The beam would be destroyed. The coherency that you're asserting would be maintained does not exist. Your position is actually invoking magic, as you say, right? We're going off a simple radio wave propagation and how it actually works functionally. Okay, what you're describing would be omnidirectional propagation. There would be no problem.
Alan,
with that.
do you understand what diffraction is?
Yes.
Tell us what it is, please, because I don't believe you.
Yes. So in the instance of a radio wave hitting a physical obstruction, as it overcomes that obstruction, it will start to fan out again.
No.
That's not diffraction. And I think we've gotten to the core of the problem here. You
For the
misunderstand.
sake-
That's not an insult. It's possible to not understand things, but not be
natural
insulted.
beam divergence versus diffraction of hitting a physical object is what we're talking about.
Can I
here.
can I share a screen for a little
Yes.
bit, like for a second? Okay, I will share a screen. 1 second. Share a screen.
Ready.
Okay. This is just like a little painting, but it's actually what we're talking about right now. Okay, and I think it's as simple as it could be. Like there's a point where you're propagating the wave, and if the wave hits Earth curvature, it's gonna diffract, and it's gonna either it's gonna diffract up against the sky, or it's gonna. This is from radio specialists. You can laugh as you want, but this is from
not-
radio
oh my
specialists
God.
again.
Yeah,
Yeah, and
Okay,
you can.
for
you
the
can
love
look-
of Pete, if you can just present his illustration.
I didn't hear you. Sorry.
I said, for the love of Pete, no pun intended if it was Pete who interrupted. I don't know who it was that was laughing. I want to
Not
give
me.
Dominic a chance to present without any audible interruption, whether it be laughs or words.
Yeah, they do all this time, but it's okay. We see who's act and who's not. This is like actually like very simple because we are actually arguing about very simple like thing, and if it's a diffraction, you still are not able to get it over the globe to maintain coherent signal. This is like if we talk about, I'm gonna stop screening. If we talk about regular like a horizontal radio propagation, then it's fine. You can like claim that there's some magical atmospheric condition. There's some magical like a skywave propagation. It's okay. We know like when Marconi sends a signal as Earth is flat on over 2,000 miles, then you have to invoke some way how it was propagated on the globe, and it's fine. Okay, but the issue with this specific mutually exclusive evidence is that the plane had to fly in the beam, and the beam had to have specific geometry, so the two beams could cross over, and they could like land a bomb on the target. And they were using this technology for almost 1 year, and they were using in the night. So you have to like have a specific like accuracy to be able dropping bomb over a year, as like over such a long distance, and with two beams. So you don't have to, if you like claim it's a diffraction, then you have to claim that from two different beams were diffracting in such a specific way that they were actually able to cross it over the target and drop the bomb on specific target. It's insanity to believe that this is diffraction, because the coherency of the beam wouldn't be the same. And if you have any math to show us, if you have any math, then show us how it could be possible. Like count it, and you can. I know that you don't have it right now. It's fine, but you can show us later. You can do some video. You are doing video all the time, so show us some video where you prove that we are wrong with actual math. That would be amazing, because that's what we are show you right here. We got the math.
Okay,
and
gotcha. Just because it's been maybe a couple minutes, I do want to give the other side a chance to respond. But I also want to mention, folks, we're going to go into the Q&A pretty quick here. But so fair to say, Dominic, you're saying, do you have the math to give a response? Anything else?
I'm not saying that they have to give me the math now. I'm just saying it would be nice if they like back it up later with some real evidence.
What's something you'd like from them in a debate right now?
Well, I did actually right now in the debate answer. We actually asked them so many times and we didn't get one single answer. How they like think that the beam could be propagated on the globe.
You had 2 minutes and it was just tell them that you need them to email you something. Like I'm saying, like what is it that you want to say? Hey, but yeah, but I mean, you're like, but you don't have to have the numbers now. You know, it was like maybe another time and say, okay, well, bring up a challenge that you expect them to be able to answer right now.
I gave them challenge that I would be able to answer right now, how they could propagate the beams and maintain the geometry of the beam if Earth is globe.
Okay, we'll give you a chance for sound, MC Tune or Peter, and we're going to go to the Q&A in just a minute, folks.
All right, I'll present here, do a little diagram, because it seems so you can. I'm not presenting. I'm just changing my screen. My camera. So here you go. Here's the Earth. Here we have the transmitter there, and let's go with this here. So let me get a straight edge. So your diagram showed reflection. In addition to, I think there was the red line. Maybe I'm colorblind, but anyway. It may have shown refraction or diffraction. So here is line of sight, but diffraction. Then as it goes around there, diffraction causes things as you're near to an object to have more and more. This is what happens in diffraction. This is diffraction, right? And a large portion of that distance was either low-lying land or water. So not a whole lot of mountains in between. Certainly there was some topography, but this is what diffraction looks like. One source here, and of course, highly polarized and extremely powerful. And so all of these waves here, no problem with these happening here. Okay, this is diffraction. This is what diffraction looks like.
So, Toon, is it fair to say that it would spread out vertically?
It does spread it vertically, and that's why it's important to have a powerful signal. But it does not, because it's polarized, it is not scattering or dispersing horizontally. At least not in a significant amount, and that's why it's able to maintain the coherent beams as it gets near the target in the previous drawing.
So it's coherent horizontally, but
Yes.
not so much vertically. Is that right?
Yep. So here's what it looks like horizontally from the top down, right? You've got this side here, and you don't see it because it's the top-down view, but it's diffracting as it goes this way. So the beam is getting tall, so there's no problem with the planes receiving it, provided that they're far enough away, right? Now if the planes were, in this vicinity here, they wouldn't. Let me get my finger right. They wouldn't see it. But when they're over England, they're in this area here, so they're able to receive that signal. No problem at all.
May I screen share really
So
quick?
this is basically an
When
issue
you're
of
done.
thinking in 3 dimensions.
I think it could be.
Yes, you may screen share, Alan. Go ahead.
All right, awesome. Thank you, sir. Entire screen.
This is the last thing before we go into the Q&A. Sorry, folks. I've got to re-enter my microphone. I'll take care of it later, but I do agree my audio is wonky. But go ahead, Alan. We're ready for you.
All right, thank you, sir. So, as we covered earlier, this isn't diffraction of an omnidirectional beam.
Just to be clear, your screen is not showing.
Oh, thank you. 1 second. Need to double confirm. There we go. Okay. So we're looking here at Dave McKeegan's video from a couple of months ago where he was asserting the same thing, making the same mistake that McToon just drew out. So as I stated earlier, this isn't an omnidirectional AM, FM radio station. This is coherent overlapping beams that make an equisignal, which geometry has to be preserved in order for usefulness of the targeting system. So what we're looking at here is the beam coming out, hitting this obstruction, and then diffracting down to still hit the car to overcome the physical obstruction between the two. This is not analogous to the system that is being proposed. What we have is the exact angles for the target or for the Derby site that we can go over. So at 660 feet, you're going to hit Earth curvature at 32 to 50 miles. And that tangent that you drew is actually going to put you following the line to the sky. When you math it out, it's going to be 111 feet over target if you're doing the distance from Stolberg to Beeston, which would be that intersecting beam that intersected the one from Cleve to Derby. So anyway, this is the summation of what you're proposing, and the bombers only flew at 19,000 feet, so that equisignal would have to be 17 miles wide, which defeats the purpose of it. It was measured by the British at 450 yards to 600 yards at the distances over target. And another thing to note, what you were saying about how it would be cool if they flew over target, there would be no problem with that. Well, they actually flew in the beam to guide them to Britain. And it was noted in the documentation for the system that you had to, the first 30 to 50 miles out from the radar system had to be completely clear. Because what we're looking at is this beam geometry, where at 3 degrees above the horizon, you would have something like what you were showing for the globe. But remember, our angles are way back here at sub 1 degree at 300 to 400 miles respectively. And then, of course, the Germans actually measured the beam and used it at further distances and whatnot. But the minimum max specs that they put in their documentation from the company who built it was that at 1,000 kilometers, the beam accuracy was sub 1 degree. Or I'm sorry, the beam divergence, sorry. So everything that you asserted and tried to, correct it on is either wasn't analogous or it's a complete strawman and misunderstanding of the technology, as was stated earlier, that maybe we weren't the ones that understand it, but it seems weird that you guys are drawing unanalogous diagrams to the radar system and then asserting that we don't understand it.
I have right here There's nothing. What's non-analogous of it? It's a highly polarized beam sent from a low elevation at a angle that matches. It's a very low angle, right? So it's going to, as you said, hit the surface of the Earth at some point perfectly fine, because then on the other side of it's diffracting, and you're getting, a large portion of the vertical section of the sky painted with that beam. No problem at all. Nothing at all an issue with diffraction doing this.
We're gonna jump into the Q&A. We'll give the last word to the Globe gang, as they were, as it was the Flat Earth who got the first word or the first speech. Thank you for your patience.
Go, Peter.
Folks. As my microphone, we're gonna get through this together. So one.
Oh, sorry. I didn't realize you were still talking. Sorry.
Go ahead. What is it that's on your mind, Peter?
Oh, just I thought we were supposed to like summarize basically, or answer or whatever.
Just wrap up the.
I don't know if you know, MC. You guys want like a closing statement?
Yeah. So, as
okay,
and
I mean, just I mean, I don't like. Then of course they would get one too. But if you're okay with that, go ahead, Peter.
Sure, I guess.
That would be fair, right? So it sounds like you're okay with it. Okay.
As Toon and I both explicitly predicted, Alan and Dominique spent this entire time completely running away from and ignoring all of the evidence that Toon and I presented. The best thing they said was, "This isn't what we want you to present. We want you to present something directly measuring the ground, not measuring the sky." Well, that doesn't answer our evidence. Simply saying "I don't want this" is not a rebuttal. So that's fun. And Dominic, I do want to say, I don't know to what degree you are being genuine, that your feelings are hurt by some of the things I said. I don't want to hurt your feelings, but unfortunately, I do have to say some hard truths here in this public forum, especially since you are both actively deceiving your audiences. So, if you threw around the accusation several times that my opening presentation and Toon's were both a slander fest, I take that very seriously. So I'd like you to DM me specific examples of things we said, not just that hurt your feelings, because that's not what slander is. Things we said that are slander, that are untrue about someone, that make them look bad. That's what slander is. I don't think either Toon or I said anything untrue. So please share with me in DMs later or whatever exactly what was slander in our presentations.
Can I respond now, me or McToon?
Let Dominic.
Go ahead, Dominic.
Thank you, guys. You weren't able to even like this, your last speech, to make it without insulting. You don't know me. You don't know me at all, Peter. I don't know you either. So that's why I didn't bring your pictures in presentation. That's why I didn't claiming what you believe or don't believe in. And I would never speak publicly that you are deceiving people, because I don't know you. I don't know what you believe in. And when I say I 100% believe on my life that Earth is actually stationary, and the most accurate depiction would be topographical plane, geocentric topographical plane. This is what I do believe in, and I would never ever lie to any people publicly, because I hate lies. I'm Scorpio. I fucking hate lies. So I would never ever lie to people publicly about my beliefs. This is my belief, and I'm here to defend my belief. So far, I didn't heard any refutation about the Battle of the Beams. Our position was that Earth is a planar, and the measurement of curvature are dependent on the position of celestial bodies. If Earth is a globe, you should be able to measure curvature independently on celestial bodies. I did some measurement on the ground, and all the measurements, I physically went out there and I did measure the Earth, and the measurements went that Earth is flat. I didn't found the Earth curvature, and I will definitely send you the list of all like attacks and fallacies that you did. I actually like got rewritten right now, so I will send you as we done. I can send you right away, and it's for me it's very sad that you spend all this time to attacking us instead of the arguments, because our arguments were very clear. We didn't bring any insult, and I don't think that you are a wrong person because you believe that the earth is globe. And it's very sad that you actually believe that we are like bad persons because we believe in something different than you. And in the end of the day, it's a belief from your side and it's a belief from our side. But our side actually realize it, and your side thinks that it's backed up by all the science, and it's not. So that's my position. And it was a nice time, guys, really nice time. But if it were without the insults, I would enjoy it more.
We'll go to MC Toon.
All right. Well, thank you, Dominic. You're a little too sensitive. Alan, I do love debating you. It's always engaging, and so I look forward to it. I look forward to future debates with you. We did not choose to use measurements of the surface in this particular instance, Dominic. It's okay. We get to choose what we present. You get to choose what you present. That's the cool thing about me deciding what I do, right? But if you wanted to do some sort of debate where it was limited to ground-only measurements, that would then be an instance for you to say, how come you didn't bring ground-only measurements? You see how that works? So if somebody wants that, hit me up. I'd be glad to talk about that. Anyway, this has been super. I look forward to the Q&A.
Alan, last word.
Thank you, sir. So fair enough about the evidence is presented, but as you'll note, my premise was your guys' conclusion, and we're not able to come away with any mutually exclusive evidence if we're referencing the same things and whatnot. That's why there was additional evidences, but this is a free for all, and we didn't swap sources or anything like that. So it's you got to take what you can get when it comes at you. So it's all good in regards to that. And thank you for the debate. It was a lot of fun, and that's it for me. Peter, it was nice to meet you. Toon, pleasure as always. Dom, you crushed it, bro. Your English is on fire, bro.
Thank you, guys. I'm sorry if I misspoken or something like that. It's for me, it's quite hard to speak in English and also think in English. It's really different thing, but it was really nice debate. I would have to actually go because in my time is 4:30 in the morning, and I actually have to go get my dog, take him out, and then I have to go to the work. So for me, it was a pleasure. Thank you, guys. I think that you should look on people who believe in something different than you differently, than not just they are liars and bad people. Because I don't think you are liars and bad people. I think just you believe in something different than me. And I think that's perfectly fine, guys.
We'll jump into it. This first question coming from, thank you, Dominic, for coming with us today. It's been a tremendous debate. We'll let you go. I hope you have a great rest of your night.
But thank you, guys.
Yeah, I actually have to go as well.
Was that Peter or Alan?
Alan.
I don't know if you guys know, all the questions are for you. So we're going to have to read them, and you're not going to get to respond to them. That's just our policy.
That's unfortunate.
Yeah, my dog is definitely going to cry about it, but it's going to do what it's going to do.
Well, Dominic, I don't blame you. I have no idea what Alan's excuse is. Dominic, you're excused. You just click out of the call. You don't have to
Yeah.
Your English is great, Dominic.
Alan, if you have to go, you have to go.
Yeah, dog, your boy's got a dip, bro. I do.
You're a bunch of greedy turds.
I do actually have to go. See you laser, dog.
super chat for you guys.
Yeah.
Nobody's gonna
And he's
answer.
out of
So
there.
sad.
Couldn't fuck a give, boys. All right, we're
This
still live on
maniac.
YouTube. Shout out to the lads on YouTube that stuck through it.
Man.
Thank you guys.
Yeah, great. You guys destroyed them. That was an
Absolute
absolute
massacre.
slaughter. It
Ugh.
was devastating. He just said "nuh-uh" super hard 7 times in a row.
There was a 10-minute delay or some delay trying to get his video. They had to get over there, and it was all you guys are stupid.
Dude, I was so mad that I waited for that because like I saw a couple slides in the preview thing and I saw our faces on it and I was like, all right, well this is gonna be, pretty much useless. And I mean, I wasn't wrong, right? My hypothesis wasn't falsified, dude. It still stands.
I could not believe that. And then he had the goal to later on act like you guys were taking up too much time or something.
Yeah. Crazy, bro.
Well, they
Yeah, that
can't
was-
even get the stream right. It's still messed up right now.
Dude,
I think it's funny. You guys both bailed, and Dominic beat you too. And I think that's the funniest part. He was like, "My dog, you're gonna go now."
But all the questions are for you. I thought it was funny. You're like, well, that sucks. I'm out.
He's like,
No,
"Oh yeah,
maybe you can pay me then.
I
Yeah.
give a fuck. See you later. Bye."
We still live?
Yeah. Yes, we are.
Should we continue watching this? Garbage?
Absolutely. Oh no. No, that's
Okay.
that's the past. You're living in the past, my man.
Thank you.
Yeah. All right,
I
lads.
was really hoping for some type of rebuttal to Battle of the Beams.
Nah.
Then pick up the pieces by themselves or whatever, and then stroke each other until everything feels better.
Good job, Alan. Dom slayed it.
Yeah, you
It
guys,
sucked that they broke up your guys' intro though. That really sucked.
Yeah, that really killed the
Forgot what you
momentum.
said. Dom, for your first debate, you slaughtered him, dude. If you were nervous at the start, I think you quickly realized that. Oh wait, they don't have shit.
Dude, that's what I was a little worried at the start or whatever, just pre-debate jitters or whatever. And then as he's like, the sun did this above the horizon. It's a globe. I was like, oh, thank God, dude. Nice.
Dude, that Venn diagram or whatever kind of diagram that was, that made no sense. It was just like so cartoony.
and this one guy, robotism or something. He believed it. What the fuck was that?
Dude, you remember that one comment I said before? I was like, oh shit, hold on.
I wasted $10 on the super chat, but I just wanted to put it out there like, hey, can I post this link to the presentation that Alan's presenting?
Oh, nice.
Can't do it though, but I managed to put the link there a couple times.
Nice.
I was like, so the audience can follow along? I think it would be great.
One for the lads, huh?
Yeah, I like how James was eating his Subway at the end.
Yeah. Yo, Sam, are you there? Samuelson?
I bet he's sleeping.
Shoot.
Yeah, it's late for him. Or early, I should say.
It's early. We have a same timeline, I would say.
Dom, you're gonna feel so good going to work. Like, yo, I just slayed first debate.
You killed it, man.
I think that like Alan killed it, but I think it was good for me because I was able to give Alan space and like change the direction of the debate because that's how I presented myself as a like Czech folk and with issue to English. They were kind of nice for me from the start, I would say. So I think it was good for me that I could like change the topic of the debate and move us to the something that is nicer. Because if Alan did it, they would be like, "Oh, you are running away." But when I did it, they couldn't like say shit. So I think that was like really good.
It was a great transition.
Yeah. And then Peter having issues.
Peter was there like he could like leave on the beginning and it wouldn't change the shit.
Dude, right? Z, your boy Zero Impact, bro. ZDPS, dude. Dude showed up in
Zero.
full white gear, just fucking missing every attack.
Dude.
He was actually like hitting his own like a son. He didn't like know who is the boss, and was like actually focusing all DPS against Mech 2.
Hindering his team. Dude, Boy Jenkins every
Yeah.
encounter.
He was throwing
Shane,
heals on us and shit. Yeah. Anyway.
I hope Shane muted me for how much I was laughing when that was happening, dude. Because I was dying.
You ruined their whole recording, but I didn't do anything about it the whole time.
Nice.
Okay.
Respect.
It was.
All right,
it was
lads. I'm
amazing.
going to wrap up the live stream. I'll be back in a few.
Yeah, I have to go with my dog, but I will put you on my headphones, so I will be here in a minute.
Word.
Go get it, man.
Pops on following through on the egg.
All right, lads and ladettes. Thanks for showing up tonight. Hope you guys enjoyed the old debate sesh where their conclusion was my premise. So that was fun. See you guys tomorrow what is tomorrow? I don't even know what day it is, lads. Tuesday. Okay, yeah, we'll be doing something on TikTok tomorrow for Wednesday or Thursday. So stay tuned for that. And then, of course, Friday will be Flat Earth Fridays or a community-held space if there is no Flat Earth Fridays because they're on vacation for a couple of weeks. So we'll see what happens there. And then, of course, Globebusters will be on Sunday. Make sure you tune into that. Thanks to everyone who supported the channel. Much appreciated. See you guys later.